All right. All right. So we have Jamie Brown here. I am Joshua James Bolliero, and we are going to talk about the Earth and and what it really is versus what we thought it was. And so yeah, this has been a long time coming. I really like having Jamie on here. I've known Jamie. He's been in the flat Earth community for a couple of years, and always speaking out and not afraid to speak his mind. So I really appreciate him coming on, and hopefully we can all learn from each other, and maybe I can explain my perspective a little better, and there we have it. So, Jamie, would you like to introduce yourself and give us a brief rundown on your experience?
Yeah, well, it was around 2016 I was like introduced to the concept of a flat Earth. Um, so yeah, kind of started doing the research into all that and hearing about all the things um, like you know what is level and what you can see further distances than you should and um, on a globe that is and oh uh, yeah, so that was like things like that made me start questioning if we live on a globe, and then I did more and more research, and I was like, no, we don't live on a globe. but
Right.
then but then I started to see stuff from the opposing side, of like the globe, that certain things could be explained, like some of the things like in the model, it has an explanation. So as time went on and I started to learn more and more, I kind of started to kind of doubt things. I was like, is this really right? Because some of the arguments that I would have used at the beginning, like the horizon and stuff like that, the horizon being at eye level and all that. I mean, I had to kind of not really use that anymore. And the crepuscular rays, even, that was something that I kind of started to think, well, that doesn't really prove either. Because the perspective and all that. So, and then I started seeing things like, like like auto levels and stuff, and I was like, how is this explained on a flat Earth? Like how is it really? I mean, it, it seemed like the angle didn't match up, and
Mhm.
and I heard stuff about perspective, and I was like, okay, maybe this could be an explanation. But as I looked more and more into it, I still felt like I couldn't really justify how it really worked out. Um, but I always keep an open mind that maybe I'm missing something, and I'm kind of that there might be an instance where the light can bend in such a way to give it that appearance. And yeah, so I've kind of just been um, trying to reason with all the different models. Like I was considering like a more of a geocentric model for a time, and then I considered some other thing, maybe a simulation or whatever. I've considered pretty much everything that's out there, um, as far as I can tell. I think, yeah,
Cool. Awesome. Yeah. So I mean, it's a similar story for most flat earthers or concavers. Um, right around 2014, 15, 16, a lot of us started coming across flat Earth information, and we no longer believe that we did things like land on the moon. Um, we don't believe things like they have all these Hubble space telescopes and all these other things out there billions of miles away taking photographs from all these crazy distances and all that stuff. Um, so yeah, you and I are probably both pretty confident that we don't live in the heliocentric model of the universe. You know what I mean? So I'm pretty sure we both believe that the Earth is stationary. Am I right?
Well, it's just I've looked at stuff on that, and it's just I don't really know enough about it. It's that people have talked about ring laser gyros and things like that. I mean that might
Sure.
not prove out at all, but I keep an open mind. That maybe it does show rotation. But
It shows.
I
It
mean,
definitely shows that something's rotating. You're right.
yeah,
It definitely
yeah.
does.
I think that's kind of it's like that's when it comes to like interpretation, isn't it? Because
Sure.
it's like when you see the stars appear to move, you can say, well, that could be because the Earth's moving or the stars are actually moving.
Right. Well,
But then
something's
they talk
moving.
about things like what is it, like red shift and things like that, and that's why I was looking at that and starting to doubt even that, and I was like, because as when they supposedly were able to detect that these objects are actually drifting further and further apart, that would kind of imply that the universe is expanding. I mean, but I was getting into all that stuff like just to see if I could, if there was any like proof of it. But it's really kind of it gets all really technical and
Yeah.
like because I've heard there's like a counter argument where they say it's tired light, and but it's yeah, I don't know like
Tired light, huh?
that
That's
that was
funny.
I mean that was what they were using to argue against the red shift. I think it was back in the 80s at some time when the because apparently they were supposedly measuring something, but it's like they say, well, uh, maybe it's tired light because obviously you get like the creationists that would some of them at the time would have been in denial of the um, Big Bang theory expansion and all that, and
Right. A
but
lot of
they
I notice a lot of these theories and conjecture they're all like built upon each other. So it's like in order to move forward with one theory, you have to believe you have to assume all these other assumptions. You know what I mean?
yeah that I think that's the thing really.
And the
Um,
layman, the everyday man, is just going to get lost in all that jargon. You know what I mean? And it is just going to get discouraged because the heliocentric model requires these fantastic distances and equations and all this other stuff. And I really don't think it's that complicated.
Yeah, maybe not. I don't, it's just like I was looking into like theory of relativity, see what it's all about, try to comprehend it, and then supposedly the it's the time dilation and length contraction and whatever the so like this what is it warping of space that
Oh, the time
allows
space continuum or
distances
whatever.
to kind of be stretched out or compressed in some way. I mean, because it's the space time. Was it space time continuum? Did you say?
Yeah, something like that where they're like, yeah, I don't even, yeah. Yeah, I don't even, I haven't delved into that too much myself either. Space time. Um, I don't really believe in the accepted explanation known as outer space. You know what I mean? Just the vacuum adjacent to a non-vacuum. It seems like ridiculous to me, you know. So I wanted to.
Well, talking about what you say, a vacuum against a non-vacuum. It's just that I started to hear stuff about it's that supposedly in the accepted model, it's gravity that's holding the pressure down, and that gravity it gets weaker as it goes like that. I mean, that kind of pressure gets weaker as you go further up. That's why you get the lower PSI readings as
Sure.
you go like to the top of a mountain.
Right, you're talking about like the pressure gradient, where I mean,
Yeah,
yeah, I mean that's obviously something that's true. That as you ascend, the air is different. You know, there's the pressure changes, the amount of oxygen changes, the forces change as you ascend. And so I think all that stuff is true. They're just applying the incorrect see gravity. See, they sell us gravity as a force, but really gravity is just an explanation. Gravity. See, I want to tackle this first because this is incredibly important. Once people realize that's that just because gravity is false doesn't mean that every spherical force is false. And so that's really important. So one thing I just want to smash right out of the park, right off the bat, is gravity. Because as long as gravity's on the table, we're not getting anywhere. So I'm going to destroy gravity in 2 minutes, and then we can get on to other spherical forms of the direction of weight. All right. So here's the way I like to explain it because it's a fashion that everybody can understand. And I think I'm actually gonna stop screen sharing for right now, just so I can show something. Okay. All right. So let's say I've got this object in my hand, okay, and I let it go, and it goes downwards. Okay, we've been told that's gravity, right? I'll put this up in here like this. Okay, so we've been told this is gravity, okay? So,
yeah.
so gravity is known as a force that's emanating from beneath us, pulling down towards the center of a convex ball, holding everything to the outside of a ball, okay? So, if gravity is just a singular pulling force, then why do things go up? Because, an object in motion will stay in motion unless acted upon by an outside force, which means that a stationary object will remain stationary unless acted upon by an outside force. So, this is more dense than a flat Earth explanation would be. Well, this is more dense than its surroundings, so it goes down because it's more dense than the air, and we don't need gravity, right? Okay, fine. I agree with the flat earthers. We don't need gravity because that's a singular pulling force. It doesn't explain how anything rises. The problem for flat Earth, is that they can't explain why anything rises either. Okay, because if I let this go, how come it doesn't move sideways? It doesn't move sideways because there is a force going this direction, causing this object to go down because it is more dense than its surroundings. However, that means that all the smoke and all the helium and all the balloons, they must be being acted on by a force that goes this way. So, flat Earth doesn't have a force that explains the direction of weight. The objects don't move sideways because there's no sideways forces. In reality, there's an up force and a down force. And I'll use a video to explain that in greater detail now while I talk. So in the concave Earth model, we have something called universal compression, and this is something that Nikola Tesla spoke about. Now, universal compression is a combination of forces, okay, where you have an up force and a down force. And the down force is strongest, closest to the surface of the Earth, and it's weaker as you ascend. And the up force is weakest near the surface of the Earth. So, because you have both an up and a down force, then you now have that tug of war, that as above, so below. That way the object's mass, its properties, its mass, density, that will determine whether an object goes up or down, because it will determine which force takes over. And so I'm just gonna play this 2-minute video, and there's nothing crazy in here, so we can just he explains it very well, and so I'll let him explain it.
The lift force and the sink force of the electromagnetic flux. There's an inversely proportional relationship between the two. Blue arrows represent the centripetal convergent lift force. It draws objects to the center, where the current is attracted to the moving convex surface of the celestial sphere. The lift force is stronger in the center and weaker at the edge. That is why planets have such an easy time staying aloft toward the center, because there's not that much sink force and plenty of lift force. If it weren't for the magnetic sun attracting the planets, they probably would crash into the celestial sphere. The lift force cohabitates with the centrifugal sink force, which has the inverse proportion effect. The sink force is the either push force we all experience on the Earth or in the Earth. As it moves, the divergent fluxes of the brakes on the Earth, preventing any rotation. Remember Wheeler's gyroscope and his huge neodymium iron-borne magnet? The centripetal lift force perpetuated the magnet in a viscous free flux near the center. Yet the centrifugal divergent sink force stopped the gyro on the edge. That's what's happening with the Earth. The sink force generates a depression to the west. That's why bullets sink to the west and rise to the east, because there's a greater clamping down effect for projectiles shot into the downstream of the sink force.
So he's talking about the real explanation for the Coriolis effect. Obviously, motion is detected. However, we live on a stationary Earth. So how does this resolve? Okay, we live on a stationary Earth. It's gravity, quote unquote. It's universal compression. It's the lift force and the sink force, the up force and the down force. Okay, we are held to the Earth by the sink force, the pink one, also known as gravity. That's pushing us to the Earth from above. See, we're not being held to the Earth from a force that's beneath us. We're being held to the surface of the Earth by a force that's above us. So I'll let this continue.
This is also what causes eastward deflection of flying objects.
And this is also why we get the 15 degrees per hour in the gyro. It's not the Earth rotating. It's quote unquote gravity rotating.
They seek the least resistance, which will always be found eastward of the meridian. The sink force is so strong at the edge it holds the water at bay. The ether sink force eliminates the Coriolis or the Diopos effect from being the cause of this phenomenon. Since you should know by now, we are not on a rotating planet. Now we can understand what causes gyroscopes to liberate themselves from the thick sink force happening at the edge. The rotation of the gyro is stripping off its sink force hold and aligning itself with a much weaker lift force at that level to allow it to rise. The vertical axis seeks to magnetically align itself with the central octahedron. That's why the airplane gyro stays pretty much vertical wherever it flies within the Earth.
All right, so real quick, I wanted to address
this is my version of the Earth's magnetic.
I wanted to address seasons real quick, because we have someone in the chat that thinks seasons work on a flat Earth. And yes, while the data on the flat circle is just an accurate representation of the temperatures, all they're doing is stretching it out on a flat circle, just the same way the Gleason, as we all know, the Gleason and the azimuthal equidistant map have huge problems. But the seasons can't work on a flat Earth because heat rises. And so if we had a omnidirectional light ball moving over the surface of a flat circle Earth underneath a dome barrier, then all the heat would rise. The surface of the Earth would be relatively the same over the surface of the Earth. There's no, on the flat circle model with the sun orbiting around. Let me see if I can find a silly map. Hold on one second. If we have, oh, here we go. Here's one. Okay, so if we have, let me get bigger. If we have a flat Earth sun traveling around a flat Earth map, geez, I used to have tons of them. Where'd they go? Then, all right, here we go. Then if you have the sun orbiting around like this over a flat stationary, then you don't have the sun in any one place for a whole season. Where if you go like this, so even if the sun's making bigger circles like this, when the north is having its winter, when the sun's making these big, it's still taking 24 hours to go around. So how is it creating heat around the outside? You ever cook a pizza, right? You ever cook a pizza on the outside and it's raw in the middle? That doesn't even make any sense. Like, that makes no sense at all. The seasons can't work in this model. So FPV Angel, you're wrong. You're busted. You're a liar. You're a troll, and we all know it. So please stop infesting my live chat.
Well, that's not his model, though, is it? That's the AE
Right. Yeah.
projection.
This is one of the flat Earth models. However, this is a model where seasons are claimed to work, and it's just illogical. In the concave model, it makes a whole lot more sense, because let me see if I can find it real quick here. Actually, I know exactly where it is. I don't have to look for it too hard.
At the bottom of the two plumb bobs, the distance is greater. It's exaggerated here, but it was essentially 8.22 inches greater.
Okay. So this makes a whole lot more sense, because in the north, so you've got a sun orbiting around the top of the ball for a whole season. And then you've got the sun orbiting around the middle of the ball for a whole season. Then you've got the sun orbiting around the bottom of the ball for a whole season. So for a whole season, the top of the ball is being heated up. For a whole season, the middle of the ball is being heated up. For a whole season, the bottom of the ball is being heated up. That makes perfect sense. On the flat Earth, you don't have the sun in any one place for a whole season. You see what I'm saying? It doesn't make any sense that the seasons would work on this. You know, I know this is just a flat circle. Believe me, I'm aware that there's rectangular and square and diamond shaped ones. None of those hold up to scrutiny either. The seasons wouldn't work on those models either. The next thing I wanted to address was a little sociological experiment that I conducted regarding the auto level with the P900. Okay, so obviously I made several uploads, and I kicked up a big fuss about how the P900, when you level a P900, you're going to get this green dot if you're level on both axes. And I was finding that with my particular P900, I was always getting a horizon that was above center frame level. All right, I'm going to mute this. I'm going to play the footage, and you can see that with my P900, it's very sensitive, and the green dot will go yellow if you just touch the camera or bump it. I think this was one of my best attempts where the green dot didn't go yellow too much. And so I think I stopped it and uploaded this one. But if you try this a bunch of times with my particular P900, you'll notice that this green dot will go yellow. Okay. Maybe you'll see it right here. Just for a second, it'll flash yellow. Maybe not. Maybe this was one of my real sure-handed. Okay, so I think this time I got it. I got it really perfectly. Let me find a better example. No, you could just go to my channel and watch these pieces of footage. Here we go. Here's another one. So as I zoom out, oh, there we go. Okay, so that line went yellow, and so I'm trying to make the argument here that there it is. Okay, so mine's more sensitive. There was somebody else now I had offered on Facebook. I had made a post I had made a post asking people to share their P900 footage because of my experience with my auto level. Okay. Let's see if I can find it. How far away is it? Here it is. Okay, so I had made this post. The point of convergence or vanishing point determines the horizon when viewed from the Earth's surface. Okay, regardless of whether the Earth is convex, flat, or concave, that's all still true. Vanishing point, convergence, that doesn't prove the shape of the Earth. Okay, so I've recorded all kinds of footage, and I asked the quote-unquote P900 Earth community to show me their footage using their auto level so we can determine if my auto level is inaccurate, or if all the P900 auto levels are inaccurate, or if they're all accurate, or what's going on, right? Because if this isn't calibrated correctly, then all of this is a waste of time. And I believe it was. I don't think they're calibrated properly. In fact, the only person to actually do what I requested was Jenna, and she did it here, and she showed that with her P900, which is a lot less sensitive than mine, she showed that you could see hers is level, and she's keeping a green dot, and she's going above the horizon, below the horizon. Look at that. So she's going way up and way down, and her dot's staying green. Now, I have a totally different experience with my P900, which means that with just using two P900s, I've ascertained that one P900 is different from another. So since one P900 is different from another, then that means that that all of my optical evidence of the horizon being above center frame is worthless, because I can't prove that my horizon is actually that mine is actually calibrated properly. I do know that mine's a lot more sensitive than hers, but that doesn't mean that it's accurately depicting level. So I'm going to take those claims and throw them out the window. However, I've made some other observations that can't be thrown out the window. And so I'd like to address those after I'm done with gravity. So, yeah, let's tackle that first. Let's finish tackling that. Obviously, you can,
seasons within a
so, you can obviously tell that seasons make sense in this model. This obviously isn't proof of any model, but what I'm saying is that as throughout the year, the sun is going to orbit the top of the ball, and then throughout the spring and fall, the seasons on the heliocentric model don't make sense, because we'd have to be orbiting around like this, and that just doesn't make any sense at all. In the concave Earth model, the seasons make perfect sense, and of course it matches with all our daylight data, and we still have half a globe being lit up instead of trying to figure out how it works on a flat circle, which is something that I thought I explained pretty well when I was viewing the Gleason not too long ago. I was talking with somebody else, and I've taken Ronnie and Jason's their map and their model, and what I've come to realize is that every flat Earth map or model or projection is just that. It's an unwrapping of a globe. You see, you can unwrap a globe into a flat circle, but you could also take a globe and unwrap it into a flat square. You could take a globe and unwrap it into a flat rectangle. You could take a globe and unwrap it so that it's not even any of those, so that it looks like all kinds of different like jagged edges. You can unwrap a globe any way you want, but that doesn't make it an accurate map. The only accurate maps are globe maps. However, there's something that people are failing to understand about the difference between concave and convex. it's really important to understand that, well, people will ask, well, wouldn't the curvature be the same on the inside of the ball and the outside of the ball? And my answer would be, well, yeah, we're still talking about an 8,000 mile radius ball. So of course, the curvature is going to be the same rate. However, the problems with the globe maps are this. Flat Earth has discovered problems with the continent sizes, the continent locations, the ocean sizes. There's anomalies there that don't make sense. And the reason why is because of the lines that we've drawn on the Earth. See, outside and inside, the Earth would be the same. The dirt, the water, the trees, the grass, all that stuff, the plants, the animals, all that stuff would be the same. However, the lines that we would draw on the inside of a globe would be different than the lines that would be drawn on the outside of a globe. And this is why. And so if you don't have the correct globe, then you're not going to have the correct continent sizes, based on the lines, the units of measurement that mankind has created. That's all going to be different. And so that's something that's really important to understand. And when I realized, when I first came across flat Earth, of course, we're told, yeah, for thousands of years, people always knew the Earth was flat. And then came along this Copernican deception. So then you start looking up all the heliocentricity and you find out all that stuff is true. Oh, yes, this heliocentricity idea, this really is when it all came about. And so you're tricked into thinking, oh, okay, well, the Earth was always flat until these clowns with the spinning ball came along, right? Well, that's what I would have thought too. However, there's a huge problem with that. The problem is that the amount of flat Earth maps that you're going to find throughout history is practically non-existent compared to all the globe maps from history. And you'll notice the difference between a concave globe map and a convex one. Remember, I showed the difference before here. How the areas of longitude will diverge instead of converge here. So when I look at all these old maps throughout history, not only are they globe maps, but they're not convex maps. They're all concave Earth maps throughout history. And so even if there were flat Earth maps throughout history, that doesn't prove any shape, because even today, we have flat and concave and convex understandings of the Earth. However, to make the claim that people always knew the Earth was flat for thousands of years is ridiculously false, because when you actually look into it, there's not this many flat maps, not even close. There's hundreds and hundreds and hundreds of concave Earth maps throughout history. It appears to me that people always knew the Earth was concave until flat and convex came around. I can make that same argument, but I've got all the maps to back it up. Where's all the flat Earth maps to back up the claim that for thousands of years, people knew the Earth was flat? You better have a lot of flat Earth maps to make that claim, and there isn't any. Concave maps are the only ones that can make that claim, again. So I want to make that point very clear, because until someone realizes just how many concave Earth maps there are, they're always going to be stuck in that paradigm that well, any spherical Earth must be a psyop, because people always knew the Earth was flat. If you have that false pretense, then it's going to be very difficult to break out of the flat trap. So I wanted to point that out. That'll shatter a lot of people's confidence. They'll be like, oh, whoa, wait a minute. What do you mean? Oh, people didn't always know the Earth was flat. Oh, but it wasn't always a convex spinning ball either? Oh, okay. That makes sense. Another false dichotomy. And you'll notice that this whole cosmological community is loaded with false dichotomies. there's always two wrong answers for every right one. They've made sure there's at least two incorrect directions to go to hide the truth at all times. And so I think I covered seasons and the gravity and my incorrect assertion with the auto levels and the P900s. I've got a lot more, but I want to give Jamie a chance to speak. So I'm going to shut up now. Jamie, what do you got?
Yeah. So talk about like before he was on about like the lift force. I mean the sink force and the lift force.
Correct.
I was thinking that in the accepted model, they would say that the reason why things lift is because of supposedly things are getting pulled. I mean, due to gravity.
Right.
The denser objects are being, or the more massive objects are being pulled, as opposed to the less massive ones, and the less massive ones that are beneath the more massive objects would be, because there's more of a force on the more massive objects, the less massive objects would be forced up. I don't know if that even explains it, but it kind of makes sense to me in a way. But I suppose it'd be like equal and opposite reaction kind of thing. Like,
well, what I wanted, okay, so we have the Cavendish experiment, right? And so there, and others, there's been experiments where they put two objects near each other to see if they attract. Okay, and there is an attraction. However, I understand. I'm just going to read this quote and then I'll talk about it. So Nikola Tesla says, a good example for such an interaction becomes apparent in gravitation, which should rather be named universal compression. I think the material bodies do not gravitate between each other, but it is the ether that makes one material body press to another. We wrongly call this phenomena gravitation. So if I have two objects next to each other, and there's an attraction there, does that mean that each object has a force within it that's attracting the other object to it? I would say no, and I think Nikola Tesla also would say no. What he's trying to say is the attraction, the force is coming from the air. It's the air, it's the ether, it's the air, it's universal compression itself. It's the forces in the air that are causing these two objects to go to each other. There's no forces within the objects. You see what I'm saying? So it's got to change the way we think, the whole transition. And I think that's what flat Earth is still very useful. What flat Earth does is it just says, okay, we're going to eliminate all the forces. We're going to eliminate all the curvature. It literally is like a Earth education reset. That's what flat Earth, quote unquote, is. Okay. So we don't know if there's any curvature. We don't know if there's any space. We don't know how far away the lights are. We don't know what's causing things to go up and down. It's just like a whole reset. We're going to ignore all science and just start over. And you guys can just all argue with each other and figure it out for yourselves. Some of you are going to make it. Some of you aren't. That's what flat Earth is. It's not a truth. It's a reset so that each person can kickstart their journey and get a shove offshore so that they can start learning truth. Flat Earth is there to wake people up so that they realize they need to start seeking truth. I don't see flat Earth as a truth. Flat Earth is a reset to find the truth. I think the same way about the Bible. I don't think the Bible is the ultimate truth. It's there to bring you to the truth. Hence, that's why Robbie Davidson's always doing that flat Earth and the Bible 24/7. Is because both of those things are tools to lead you to the truth. What did I pull up here? Oh, okay. There was this a quote from Hitler or something. There was a different one. I guess it really doesn't matter, but yeah, a singular pulling force doesn't work. So the heliocentric model, that doesn't make any sense. Flat Earth doesn't have any forces. They just chalk it up to to buoyancy and density. That doesn't work. You can't just have, there's obviously forces in the earth. You can't just ignore all the forces like flat earth does. Universal compression inside the concave earth is the only one that makes sense, and it's the only one that has any evidence behind it. So, and that would also explain, you know, I understand that when Bob Nodal was doing the whole ring laser gyro experiment, he did try it like a Gauss chamber. He put it in a chamber to see if that would block whatever was causing movement to the gyro, and it didn't. So that just means the Gauss chamber doesn't block the force. Whether it's gravity or universal compression, it just means that the Gauss chamber doesn't block whatever force that is, because they were still detecting a movement, which doesn't necessarily mean it's the Earth moving. It could still be the sky. I mean, flat earthers claim that it's the sky moving, not the Earth. So that should be their first clue as to why the ring laser gyro is moving. It's because it's the sky that's moving. And so that's what's causing, you know, your Coriolis, and that's what's causing your ring laser gyro to, that's why it makes it look like there's 15 degrees axial rotation to the Earth. It's not. It's just 15 degrees axial rotation to the sky. And it's because that's where gravity is coming from, is the sky, not the Earth. Gravity comes from the sky. Yep, that's what I just said. Gravity comes from the sky, not the Earth. You know, whatever. The term gravity. You know, we could replace any word. You know, I could just say whatever. Gravity is just a label that people used back then. Well, 500 years ago, they didn't have any way to prove any of this stuff, so they're just like, gravity. Yeah, we'll just use that. we'll just say gravity. But nowadays we can actually test the stuff. We can prove what's what. You know, we know that gravity is actually magnetism based. So did you have any more gosh,
any more what?
Do you have any more tidbits to say before I rant for 20 minutes? No.
No, it's fine. I was just because there's just, for me, it's an issue that I can't really get past is how when like you're seeing these diagrams of it, and you see the light bending like, you know, in like an arc toward the center, like it's constantly bending upwards.
Yes, I see what you're saying. Yeah, you're talking about all these like visual aids or memes, where you have I'll find a bunch of those for you. Here's one example. Okay, so this one I think has to do with the barrier. Great point. So most of these, you'll notice most of these concave, you know, visual aids, they're gonna show the firmament, which is, I think, another great point. So in here he's talking about let's see, out of whose womb came the ice, and the hoary frost of heaven hath gendered it. The waters are hid as with a stone, the face of the deep is frozen. Okay. So this particular one shows like the sprites, and the sprites originating from somewhere down here, and they shoot upwards and downwards. I want to find a different one that shows maybe why we see ships' hulls being obfuscated hull first. Oh, by the way, the people who are looking for aliens tell us there's a glass sky. Just thought I'd point that out, that the SETI Institute is aware of a barrier in the sky. Here we go. Okay, number one. All right, so this is two birds with one stone here. Number one, this brings to light that flat earthers like to measure one side of the lake, and they like to measure the other side of the lake, and they like to conclude there's no convex hump of water in the way, therefore it's flat and we can all go home, right? Because it's the same height over here as it is over here. So we're obviously not looking through a convex hump of water, so Earth's flat, right? Okay, all done. We can go home now. Oh, no. What? Oh, measure the middle, but we're supposed to keep it flat. That's not the script. Oh, no, measure the middle anyway. But what if? But that's not flat. Exactly. That's the point, and that's why you don't see flat earthers doing this. Is because they know. Number two, you can see here how only a portion of the ship is hidden, and it's because our line of sight. So we see in a curved line like this, which would affect this laser a little bit. So, I mean, maybe this should be 38 or 41 or who knows. But, I mean, this is showing a perfectly straight laser beam and making the claim that our line of sight is bent. So I understand that it's a little bit misleading. However, our line of sight is still bending upwards. Like they probably could have drew a little bit of concavity to this line here. Stronger beam will bend less. Now, light is always going to bend toward the more dense medium, and I'll show that in some footage of experiments later. So as the ship goes away, you're going to see that our line of sight is curving upwards more than the water is curving upwards, and the boat is obviously going to follow the curvature of the water, and our line of sight is not going to follow the curvature of water. Therefore, things get obfuscated hull first. Being able to zoom out on a boat that you couldn't see with no zoom, and then being able to see it with zoom, does not prove flatness. But it proves that we can see way too far based on the convex Earth explanation of refraction. Increased refraction should decrease our viewability range on the convex Earth. So to say that increased refraction, Tom Coombs in Chicago, right? Increased refraction will not give you the ability to see Chicago from across Lake Michigan on a convex Earth, Tom. Increased refraction would reduce your ability to see further, therefore making it even more difficult to see Chicago from across Lake Michigan on a convex Earth, Tom. That being said, the only way we can have bending light and see the distances that we're seeing is in the concave Earth. Of course, flat Earth likes to reject bending everything because bending anything disproves their flat Earth, and that's something that they're all hiding as well. I've seen many claims from flat earthers that make the claim light doesn't bend, water doesn't bend. Well, all they're doing is lobbing me softballs right over the plate because I'm about to show you bending light and bending water. All right. So here we go. First, we'll just do the bending light because it's so quick and easy. It's done. So Rob Skiba, here's your bending light theory in your face. Okay, so as we all know, the bottom of this tank of water is going to be more dense, include more pressure than the top, right? So light is going to bend towards the more dense medium, and that's exactly what we see here. The light is bending down towards the more dense medium. So that would conclude someone to say, well, wait a minute. If light is bending towards the more dense medium, well, what's more dense, Earth or the sky? And people would say, okay, well, the Earth is more dense than the sky. So therefore, the light must be bending down. We must live on a convex ball, right? Well, not necessarily. Because in the concave Earth model, you have, like I mentioned before, you have a barrier above your head that starts at 100 kilometers, 62 miles. And then on the other side of the Earth, you have another 62 miles of airspace over here. So we're talking 124 miles of airspace. To complete this 8,000 mile diameter ball, this is just a celestial sphere. inside the concave Earth, okay? So if we only have 120 something miles of airspace for a total of 8,000 miles diameter, that would mean that the heaven inside the Earth is way bigger than our living quarters. We only live in a 62-mile thick spherical layer of air. 62 miles on one side of the Earth, 62 miles on the other. But the Earth is 8,000 miles wide, which means that heaven inside the Earth takes up way more cubic volume than we have to live with. Therefore, here's your dimensional transcendentalism, right? There, you don't need any of that. It's simple volumetric data. Heaven is inside the Earth and bigger. Heaven is more dense than our air. So because heaven itself is so dense compared to our little 62 miles of air, there's life in here. Here's your aliens. Here's your God. Here's your gods. Here's your reptilians, whatever you want to attribute it to. They're all in here, and they're all above our head, living inside the Earth in the center. Okay, so that's more dense. So that's why everything bends upward, is because heaven is more dense than Earth. So that's one example of bending light. Here's another. This is why we can't see heaven. In the concave Earth, you have concentric layers of, what a coincidence. You have concentric layers of spherical glass that usually aren't shown in most of Steve's work. So keep that in mind. You're seeing a celestial sphere rotating in the middle of the Earth. He's not showing you all the layers of glass around it. But anyways, this is why we can't see the firmament. This is why we can't see into heaven. You know, even Scripture tells us that aside from Scripture, here's science. Scripture and science are going to, in concave Earth, Scripture and science always complement each other. More so than flat Earth in the Bible. Concave Earth in the Bible fit better than flat Earth in the Bible. Nowhere in the Bible does it say the word. One time it says the word flat, and it's only talking about setting up their tents on a flat surface rather than trying to set up a tent on a hillside. So you'll find the word FLATT Earth in like the 1537 Matthews and stuff like that. And jokers will try to use that to prove a biblical flat Earth. Look, there's the word flat. They use the word flat in the Bible. That means the whole Earth's flat. No. Picard saw upward curvature. He was seeing the entire Earth's surface. No. So that's bending light. And you can clearly see that there is no spoon, Neo. It's not there. You can either bend the spoon or bend the light. So there's bending light. Knock that out of the park. Home run. Next, bending water. So real quick, I'm going to show you bending. I'm going to show you two forms of bending water. I'm going to show you a stream of bending water, and then I'm going to show you perfectly still water in a dish, flat and concave. So there's water bending. Now, people are going to look at this and say, well, that doesn't prove the Earth is concave. No, it proves water does bend. That's it. That's all I wanted to say about that. Next, water does bend. There you have it right on the screen. Next, I'm going to show you a plate of water. I'm just going to move through these real quick. We can do a lot of talking after. Oh, here we go. I'll show this real quick. All right, so this water is actually moving downwards, but the point is that to say that all water is always flat is obviously ridiculous. Here we have spherical globs of water just being, those are descending. You can see he's filling the glass with it, but we can control water. Look at this. That's not flat. That's bendy water. That's spherical water. And humans are controlling that. If we can do that, then where is the scientific evidence that all water is always flat? Sure, you can make water look flat, but that doesn't mean that all water is always flat. Wrong. There you go. There's non-flat water right there. Here we go. So I'm going to move on to the next one. I'm just going to play this video. Let him talk.
Straw here is Zachary.
This is Zachary. He's a smart fellow.
Hello, everybody out there in YouTube land. Good times for all here, Zachary Zabal, if you prefer. In this video, I would like to show you, well, I am showing you already, still bent water. There's no electric current running anymore. All the static electricity is in the lid. That is a metal lid right here with rubber around the edges so it doesn't discharge off the edge. We have a discharge ball, kinda, metallic spray paint on a ping pong ball, on a shish kebab skewer, setting on the Van de Graaff with a tape roll separating it. Now what I've done here is I've charged up the plate to be positive. And then what I did was I discharged the Van de Graaff generator. And so the only static energy is between the plate and the discharge ball up here, the plate and the ball. And what it's doing is it's bending the water. You see that? I'm going to discharge it here and I'm going to let it go down. There you go. That's what it should. Oh, it's still got a little bend to it. There we go. But see that now? The water is flat now.
So now you can see in the reflection that the water is relatively flat. I assert it's still ever so slightly concave, but you can see here based on the reflection, it's not all like this pattern matches this pattern. It's relatively flat, where before it looks like this. See the difference? So this water is obviously nowhere close to flat, where this water is, for all intents and purposes, flat. So we can bend water using a source above the water. So there you have it. Bendy water, bendy light. So there's two more flat earth arguments that are just squashed by a former flat earther. So what are your thoughts, Jamie?
Yeah. Yeah, because I keep hearing this thing about water is always level, and yeah, it gets really old now about, and it's like they now even call it level Earth now, and it's like, but obviously there's when you're talking about a ball, level is to do with what that it's the same height from the center of it. So
yeah, there's something. I mean, there's something else I wanted to say about this term level. Okay, and I'm just going to use my little. I'm going to use my little research flat Earth globe. That I've used this in experiment. This is just a little demonstration tool, if you will. Okay, so let's say, let me find a little something. Here, I'll just take this little. All right. So this thing. So we've got a flat surface. So obviously, the easiest explanation for level on a flat Earth, you've got two things that are parallel would be level. Okay, so level makes sense easily on a flat surface. You would just say anything parallel with a flat surface is level. That's all easy to understand, right? Okay, so on a globe, you can still have level. Now, this is a globe that I don't believe we live on, but level still makes sense on this globe, folks. So for flat earthers to say that level only means flat Earth, stupid, okay? So you have the center of this globe, right? Okay, so anything so this would not be level to this globe. You see that? This is not level. Maybe turn this brightness down a little bit. Okay, so this is not level. You see that? Because it's not perpendicular to the center. If I take this, let's say this is an airplane, right? and I make this like this, this would be perpendicular to the center of the globe. Therefore, it would be level. So no matter what, even if the airplane's flying around like this, as long as this airplane is maintaining its perpendicularity to the center, it's going to be level. See what I'm saying? See, this would still be level. This would not be level, but this is still level because it's still perpendicular to the center of the globe. And so it works in the concave Earth model as well. You have a curved surface like this, but as long as you're parallel with the Earth, because not only are you maintaining distance from the Earth's surface, but you're also maintaining distance from the sky surface, the ceiling, the firmament, the barrier, the Kármán line, ionosphere, whatever you want to call it. So, of course, there's all kinds of people doing yard work. I got lawnmowers and buzz saws and weed whackers. Everybody's doing yard work around right here, right now. Of course. Can you guys hear that? Can you guys hear all the lawnmowers and shit? No. All right. Cool.
Yeah, I can hear a bit. Yeah, in the background.
Oh, can you? Yeah, of course. So I'm just going to work through that. I'll just talk louder. So that would make sense. I mean, I'll show it you can just see it. It's pretty simple. As long as you're just staying parallel with the Earth's surface. So as long as airplanes, somebody else wanted to talk about the airplanes. Yes. The airplanes would have to nose down to fly over a convex curvature, right? So flat earthers make the claim, how come pilots don't nose down to adjust for the downwards curvature of the Earth? And that's because we don't live on the outside of a ball. But there's lots of evidence that suggests that airplanes nose up. So why would airplanes nose up on a flat Earth? That doesn't make any sense. Why does the Concorde have to nose up minimum 5.5 degrees when it's going, over 700 or something like that? Mach 1 or whatever it was. Airplanes are nosing up, and even if airplanes didn't nose up, the wings relative to the fuselage are always inclined, meaning that even if you have a level cabin, where you have an airplane that's not nose up at all, it's flying 0 degree, it's flying straight. It's not going up 1 degree, it's not going down 1 degree. The airplane's wings are still angled upwards with a level fuselage. So that airplane is still going to generate lift, even though the cabin is perfectly level. The cabin isn't inclined at all, but the airplane is still generating lift because the wings are angled upwards. So now if we've got airplanes where the wings are angled upwards and the nose is angled upwards, that would be one way how they're trying to hide the concavity, is because they can divide it in two. Because if they didn't angle the wings up, then they'd have to nose up a lot. Do you know what I'm saying? If they didn't angle the wings up relative to the fuselage, then they would have to nose up even more. So to hide the fact that airplanes have to nose up so much, they angle the wings up. Then they don't have to nose up so much, so the pilots don't notice. That's something that I'm bringing to the table that I haven't really heard any other people make that argument. Everyone's talking about the nose angled up, but no one's talking about the wings being angled up as well. And so it makes all the sense in the world that, yeah, we're flying around. Yes, on the other side of the Earth, there's people upside down from you because flat earthers can't explain. Flat earthers like to joke around. Oh, show me stuff upside down on the other side of a ball. Well, flat earthers can't show you anything on a flat plane. You see, if you take all the cities of the Earth and you connect them together, God, that guy's annoying. What is he just doing? That one spot right outside my window for half an hour? Oh my God. What is the problem? All right, so let's say you take one city and you connect it to all the other 99 major cities, right? So you're going to end up with lots of lines. If, let's say, Paris is connected to 99 other cities, and Rome's connected to 99 other cities, and Moscow and Boston and LA, whatever. So now you've got this massive web of cities all being connected by lines, okay? That web of cities cannot be laid out on a flat plane accurately. It's been what? It's been, well, let's see. Math uploaded his first Flat Earth video in 2011. So it's been 8 years for Flat Earth to get its shit together and get a working map. 8 years. 8 years. 8 years of P900 footage, 8 years of NASA CGI, 8 years of lack of gravity this and Neil deGrasse Tyson that. 8 years, or we'll call it 5 or 6 if you want to call, Flat Earth starting around 2013, 2014, whatever. It's been long enough. There should be an accurate flat map by now if the Earth were flat, and it just simply isn't. We either live on the inside or the outside of a globe, and it's not the outside. Your turn.
Yeah. I'm just still stuck on you because you're like, because I know you're saying like with the light bending upwards, but I was thinking like, well, when it gets into the atmosphere, that would start bending downwards then because it's going to a denser medium again after going to a less dense medium because it's denser at the surface. So wouldn't it start to bend downwards after coming through that layer of glass?
No. In the concave Earth model, you have you have light being bent and it's coming back and entering around the backside of the celestial sphere again.
Yeah, but how does that really work though?
What do you mean? How does it work?
Like how does the like I mean, so it's going through the layers of glass and being kind of bent as it's going through the layers of glass, but when it gets to through the last layer or whatever, and then what would be causing it to start to be curving around to back where it started?
Right. Okay. So in the concave Earth model, all right. So I'll touch on two things at once here again. In the concave Earth model, you have a light source emanating from the center and shining on one side of the inside of a globe. Okay. And then, so you've got light, and light is also reflecting and bouncing around and stuff. So it's all like all of heaven is lit up by this sun, and we live in this dark little air pocket. Now light's going to bend back around here, and the light's going to enter back into the backside, the opposite side of the celestial sphere from the sun. And this is actually leads to another thing that only concavers can explain, which is the selenilion, during the lunar eclipse. So this is how the lunar eclipse actually happens. This is your Rahu right here. This is your darkness area that eclipses the moon. Light is bending back around itself and enters back in here. So in a minute, I'll show the magnet that Steve was talking about, Ken Wheeler, with the iron boron magnet with the gyro, or we'll look at it through a ferrocell. You can see the magnetic field. Light shows the magnetic field, and it shows that the magnetic field is not flat by any stretch of the imagination. And so that's why everything's returning back to the center, is because of the convergence. So before I touch on that, this is showing how light is entering back into the celestial sphere. So when the moon passes through this darkness area, this is why, and this is obviously like spherical. So you know, this is just like a cutout view. So pretend you're looking at like a trumpet, you know what I mean? Like a horn. And so when the moon passes through that area, it gets eclipsed. When it almost passes through that area, that's why we have the orange moons, because the light is refracted the least. And so because red is refracted least, so that means it's going to bend less. So that means it's going to stay on the extremity here, because all this other light is bending back into the celestial sphere, but red bends less, remember. So red isn't going to bend as much, and it's going to provide this orange glow around this Gegenschein. That's what this word is here, Gegenschein, which is the darkness funnel itself, which is what the moon passes through to provide the eclipse. Heliocentricity at flat Earth, they got nothing. They have no idea how the lunar eclipse happens. They can't come close to explaining it. None whatsoever. So I want to show the magnetic field so that people can understand why we're saying that light enters, when we make the claim light enters back to the opposite side of the celestial sphere. That seems like a lofty claim until you actually see how it works with a ferrocell. And then,
yeah, it's just the thing with the ferrocell. It's the fluid in it that's like that's refractive. So it wouldn't actually be the magnetism that's causing the bending, but rather the refractive medium that's being affected by magnetism, if you get what I'm saying.
sure, I think what they're trying to do is they're trying to reproduce the ether, the black goo, if you will, that's in the sky. You know what I mean?
Now that I've never talked about before, and that will be in the 4th edition of my free book, Not Selling Anything, Uncovering the Missing Secrets of Magnetism. Okay, right now we're looking at a magnet underneath the ferrocell.
Well, I don't think I'm going to play this whole video because it's
Tim. And here you can see,
because it's like 20 minutes, so I'm not going to play the whole thing. But I'm just going to let Ken Wheeler here explain a couple things, and then I'm going to move on to another observation regarding the same topic.
see, moving clockwise, brighter lines. These are just fed by standard hardware LEDs. Okay. Now, underneath that, moving in a seemingly opposite direction or counterclockwise, you will see dimmer lines. The dimmer lines is the opposite face of the magnet that is furthest away from the surface of the ferrocell. The ferrocell are two perfectly optically flat pieces of glass, in between which is a special solution that is less than 1 micron thin. If you actually don't have this ferrocell in your possession, you would actually see holographic depth far deeper than any hologram, even the best art hologram that the world has ever seen. And this is less than 1 micron thin. But that's not what I'm talking about here. Let's first take a look at what we're looking at, then understand what we're looking at. Because descriptions are one thing, explanations are another. So here you see it. Clockwise brighter lines and seemingly counterclockwise dimmer lines. So what do the dimmer lines represent? Now, we hold the position that is irrefutable that there is a double vortex in either pole of a magnet. We think that one side is moving clockwise and the other side is moving counterclockwise, but that's a spatial vector. In reality, the truth is, and this is something I've already mentioned, I'll get to the main point here in a second. The truth is that both are moving in exactly the same direction. If you place your hands like this and move them opposite each other in a way, you'll say, well, they're moving inverse to each other. But if you look at each hand, you'll see that this one's moving counterclockwise, and on the other side, this one's moving counterclockwise. If you move them clockwise, they're also moving inversely. But if you look at each one, this hand's moving clockwise and the other hand's moving clockwise. So the vector of inverse movement is only a spatial vector. Both are, in reality, moving in the exact same direction. These curvilinear circles, okay, you need to understand something else. It is amazing, and this is the most fundamental principle of the universe. And yes, I don't care if it sounds hubristic or boastful, but I'm the first person on Earth to figure out what magnetism is, how magnetism works, and that it can exist no other way. Simplicity is divinity. If you want to talk about Occam's razor, the most simplest explanations must be the true ones. There is nothing possibly conceivable that is more simplex than this. Explaining it, however, is not simple. The explanation is not simple. Really.
All right, so he's going to get into all kinds of stuff. Half of it we probably won't understand what he's saying, but the point is that you can see the evidence, you can see the magnetic field here, and you can see the black hole in the center. Am I right?
Yeah.
All right.
Yeah.
So I'm going to go. I want to find something that's not in that list. Give me 1 second.
I've been trying to.
At the bottom of the two plumb bobs.
And I'm just going to go here and here.
These symbols derive themselves from practically every tradition of the world.
All right, here, I want to show this real quick.
We live on a flat plane.
It's flat. Seeing is believing. As these globes clearly illustrate, the Earth is round. Or is it?
It's flatter than a pancake.
They insist the Earth is, well, flat.
Oh, really?
Is this where we find truth?
The Beyond was actually a really good movie. The ancients.
Our school system has influenced the interpretations that allege
The ancient world believed the Earth to be flat.
Oh, really? Hold on a second. I'm trying to get to something. Here we go.
Of Charlie Chaplin, but wait, as it comes round, actually at the moment, this is the hollow head. Actually at the moment, it's a perfectly normal head of Charlie Chaplin, but wait, as it comes round, you'll see, or will you, that it's hollow. The back of it, coming round now, is actually a hollow mask. It appears to rotate in the opposite direction, and amazingly, the nose sticks out, although it's actually sticking in. Coming round now is the normal, correct, as it were, face, and wait again as it comes round, and you'll see this extraordinary thing like Jekyll and Hyde. Both the noses stick out because it's so unlikely that a nose sticks in that a face is hollow. So you see it as convex, although it's in fact concave, as now, and then it'll become the normal face again, there. And note that as soon as the features appear in the hollow inside, it will look convex, as though it's a normal face almost, though it isn't. As soon as the features appear, there, your brain refuses to see it as hollow simply because it is so unlikely. And this demonstrates the immense power of top-down knowledge, which can actually counter signals bottom up from the senses.
So your brain is literally convincing you that you're still looking at the outside of a face here.
Yeah.
See what I'm saying? So I'm just going to watch what happens after this. So our brain is literally telling us you're looking at a convex face. That's what we see. That's what it looks like. And we just watched the video that proves that this is not a convex face.
Refuses to see it as hollow simply because it is so unlikely. Convex, there. Your brain refuses to see it as hollow simply because it is so unlikely. And this demonstrates the immense power of top-down knowledge which can actually counter signals bottom up from
Now
the
watch this.
senses and force.
This is going to blow your mind.
extraordinary
Check this
illusion
out.
in which the sensory information of the present is cancelled by immense knowledge derived from the past, because you've seen so many faces, all with their noses sticking out. So it's just impossible to see that as correctly horror. This demonstrates the immense power of top-down knowledge which can actually counter signals bottom up from the senses and force an extraordinary illusion in which the sensory information of the present is cancelled by immense knowledge derived from the past. So it's just impossible to see that as correctly horror.
Pretty interesting stuff right there, huh?
Yeah.
So this is so since I use this in here, I wanted to bring this to light rather. So he's going to go through all the different maps and everything. But this is a mirror that I did, and I want to plug this channel every opportunity I get. Rethink Everything, great channel. He's a brilliant guy. I've met him. He's a real person. So right now, I want to move towards some of the things that I've done that I would consider strong optical evidence. Strong optical evidence that we really need to rethink this whole flat thing. You know, aside from the rectilineator, aside from the plumb bobs, which all show concavity, aside from FE Core telling us they found concavity, aside from all these different experiments from the past, I want to show something that I've done that shows concavity.
All right, I found.
So many of you have already seen this footage where I'll play it from the beginning, but basically I'll just re-narrate. So I used a cell phone. That's what you're seeing here is the cell phone footage showing that I have a very low camera altitude. So there's the water right there. And I'm just going to put this camera on the second step, and I'm going to film myself using the P900 to zoom literally right along because all the P900s, all the flat earthers, they, of course we set up our cameras on tripods and stuff like that, and we zoom out and we say, aha, my camera altitude is 5 feet and I'm seeing X amount of miles away, and based on the curve calculator, I should obviously not be able to see that on a globe. The earth is flat. Next. And that's a mistake because we're not checking to see if the curve's going up. Obviously, if the earth is flat or concave, we can see very far. So near the end here, I do a little I call it a 360, but it was really just a 180. I do a 180 here, and you'll see this in the P900 footage I'm going to show you in a second, just to prove my altitude with both cameras. So I use the cell phone to show how high the corner of this step is off the water. It's about 3 or 4 inches. And then I use the P900 again over here near the end. I use the P900 again, and I just kind of turn it around so that you can see. I actually lift it up a little bit there. I lift it up accidentally, and I'm still level with the step. So I was really low, and I'm gonna show you that now. So here's the good stuff. Here's the actual footage. I'm gonna pause this at the absolute best pause I have in this whole piece of footage is right at 3:42 right now, and you're gonna see that I'm so low to this water. In fact, I'm going to get even lower further on. You're going to see, actually, where are we? 342. You're going to see that a certain portion of this footage, see, my altitude is up here. You're going to see me drop down. I'm going to get even lower, like right here. It's going to happen pretty soon. At some point, I drop down even lower. You guys can watch this later. I'm going to go back to 342 and show you what I'm talking about. But you guys can watch this on your own time, and you'll see this boat is completely below the shoreline over there. And so is this one. These boats are way below. You can see the sand. Now, you can see this water is curving away from me. It's not curving downwards, but it's concave. There's a dip in the middle of this water. So this water is essentially going down and away. And then these boats are resting inside the dip in the middle of the lake, and then the water's curving back up again when it gets to the other side of the lake. Kind of like this right here, how we have just this very simple right here. So obviously, if the Earth were convex and we were standing here, and the opposite shoreline's over here, this hump of water would be in my way. Because that's like 10 miles from, that's like, it's somewhere between 9 and 13 miles, that shoreline on the other side. Depending on, Google Maps doesn't give you the best. I'll show it to you later. Actually, I'll show it to you right now. Because I happen to be right here. Okay, so I was right here at St. Clair Shores. And let's see, I was right here at Memorial Park. Veterans Park. Right on Masonic Street, right there. You can see Masonic, and then you see the JFK Park right there. Okay. And I was filming out this way. So the first time I had put a measurement here at 9 miles. The second time I rethought it. It's probably about 13 miles. Whatever. Either way, it's over 9 miles away. And you can see here that if I'm even seeing the other shoreline at all, the water's not convex. I shouldn't even see the shoreline at all if water was convex. So that's out. That's not convex water. That water is either flat or concave. However, if the water's flat and my camera altitude is only inches off the surface of the water, that's a huge problem, because if water's flat and my camera altitude is, that's a lot of credit. I really only think I was 3 or 4 inches, but we'll go with 5, even 6, 7 inches. I don't care. These boats are up out of the water more than 7 inches. So if water's flat, I should be zooming right into the side of these boats. I shouldn't be able to see the shoreline above the boat. The only way I should see the shoreline above the boat is if the boat is below the shoreline. And this is how the boats would be below the shoreline, is if the boats were actually resting inside the concavity of the water, like this. See, the boats are here, and I'm seeing over the boats because the boats are inside the concavity of the water. The boats that are too close, they'll obstruct my view of the shoreline because they haven't fallen. They're too close to me. Let's say I'm viewing from over here to over here. So I'm here. If this boat's too close, then he's not going to be. He won't have descended enough for me to see over the boat to the other shoreline. So boats that are too close to me and boats that are too far away will obstruct my view of the shoreline. It's only the boats that are in the middle that I can see over. And so when you watch my footage, you'll see that. You'll see that there's some boats that are so close, they do obstruct my view of the shoreline. But this boat, if there was a boat that was right near that shore, right over there, if there was a boat right on the shore, surely that boat would obstruct my view of the shoreline because it's still too close to the other shore. The boat has to be relatively in the middle of your distance. So if you're zooming across 10 miles, you need a boat that's between 4 and 6 miles. You know what I'm saying? If you've got a body of water that's 20 miles, you want a boat that's somewhere between 17 and or rather, 7 and 13 miles, somewhere in the middle. You want boats that are in the middle. When you get boats in the middle of a body of water, you can zoom right over the boat, and that shows optically that either one of two things is happening. Either the water's concave or our line of sight is bending up. And that's a problem for flat Earth. Either one of those is a huge problem for flat Earth.
Yeah. I was just wondering, like, because I noticed something with the, like, near the shore, it looked like there was like a break in the water, like it was some kind of false horizon line. I don't know. And then it almost kind of looks like there's a layer of haze or something. I don't know. It kind of looks like it's like there's two horizon lines.
Yeah, well, I understand what you're saying. Yeah, it looks like there's yeah, it looks blurry in here. I agree. Number one, I'm really close to the surface of the water, so the refraction, all that stuff, the atmospheric conditions are going to be the most extreme when you're 1 inch off the surface of the water. Obviously, you go up in a balloon when the atmosphere is less and less dense as you go up, which means it's more and more dense as you go down. So that's why if you're literally right on the surface of the water, like here, you guys can watch, I get really low. You know what? I'm just gonna play this footage, and I'm gonna unmute it. I love you. 900. It's only 2 minutes, but it's worth everybody seeing. Yep, there we have it. I'm seeing boats below the shoreline way across Lake St. Clair. And I'll be uploading this footage. This fisherman, you can see that entire sailboat is underneath the opposite shoreline. And I'm going to get even lower. I'm going to put this bad Larry so that it's getting wet. I'm going to get my P900 wet for you guys. To show you that entire sailboat is underneath the opposite shoreline. Oh, the waves are ruining my focus here. Now, with water, unless you have perfectly still water, you can't get a P900 lower than 5 inches. If you try going 3 or 4 inches, you're going to zoom into the crest. That's the top of a wave, and it'll ruin your footage. It'll ruin your focus, and you'll have to do all this other stuff. So you really can't get any lower with the P900 than what I did. And I kind of proved it. You know what I mean? It is underneath the opposite shoreline. Oh, the waves are ruining my focus here. See, that boat's too close. It hasn't fallen into the dip yet. The concavity of the water, which you can see that entire boat right there. Sorry, folks, I'm doing this by hand. That entire boat is underneath the shoreline. Whoa, big waves. Just got me wet a little bit. There it is. See that sailboat? Okay, so these are not stars. These are just out of focus lights. But you can see that entire boat is... Now, if light's not bending and water's not bending, then I should be... This boat should be up here blocking my view of that shoreline if water's flat. But you can see this water's ramping down. Look at this. This water's ramping down. And then there's the boat, and then it ramps back up again. Wow. Underneath the opposite shoreline. Earth is concave, baby. I was wrong. It's not flat. I am right on the freaking water. All right, what I'm going to do right now is I'm going to do a 360 at this altitude, just So you can see exactly where my camera is, right here, 3 or 4 inches above the water, like I claimed. The earth is concave. I love you all. Joshua James Bolliero, I love you. And it's true. I do love you. So that right there is a huge problem for flat Earth, but it's even a bigger problem for convex Earth, because flat Earth at least makes the argument, oh, well, the hallway and perspective and blah, blah, blah. Yeah, the same bullshit I used to believe too. But the convex Earthers, you guys are in trouble. Godless Engineer, Red's Rhetoric, I'm talking to you. Soundly, Wolfie, come talk to me, because you have no convex Earth at all.
Yeah, you know, like Soundly's footage where it supposedly shows the convexity because the power lines are
man, I have
meant to
so
be curving downwards. What is your thoughts on that then?
Yeah, there's so many different ways to debunk that footage. It's just a joke. Furthermore, it's only like that one Lake Pontchartrain, like that one place. You know what I mean? But yeah, you can easily tell that the Lake P footage is just atmospheric distortions. It's so obvious. You don't even need to call that CGI or whatever. The Lake Pontchartrain curvature, quote unquote.
Yeah, I mean, there's different like variables when looking over water, isn't there?
Yeah, I mean, see the convex Earth problem is that we can see way too far for the Earth to be convex. The problem for flat Earth is that they claim nothing bends. Well, even the convex Earthers prove that light bends. See, all the spherical Earth people understand that there's bendy everything. It's the flat Earthers that want to claim that there's no bendy anything. Well, that's where concave Earth comes into play, because concave Earth is the answer between the false dichotomy. See, both of these are wrong, and so concave Earth grabs the truth from this one and the truth from this one, and there you have it. Everything works in concave. There's no downwards curvature, and the flat maps don't work. And we can see far, and everything bends, and outer space is fake, and there's a firmament, and NASA's full of shit, and we didn't land on the moon, and gravity's false, and there's same stars for thousands of years. Like everything works in concave Earth. Even all the heliocentric arguments for that even all the stuff that heliocentricity seems to have figured out, that flat Earth is just like, bumping into the wall, like blind idiots. Flat Earth really is a bunch of blind idiots that don't know what they're talking about. I know, I was one of them. I was just a blind idiot that was just like unwrapping lies, and it was presented to me as truth. But in fact, nothing actually works in any of the flat models. You need that's why there are so many flat models, because you need this one to answer this thing, and you need this one to answer this thing, and you need this, you know what I mean? Like there's all these different flat models for a reason. If the Earth were flat and people knew it for thousands of years and they still don't have a map, forget 2011 with Math's video, forget Eric Dubay and his 200 proofs in 2014. Flat Earthers are making the claim, oh, people always knew the Earth was flat for thousands of years. Then when you ask them for an accurate map, they tell you, oh, well, flat Earth is new. We haven't mapped out the Earth yet. Really? But you just told me people always knew it was flat for thousands of years. Now you're telling me flat Earth is new and you guys don't have your map worked out yet? Well, which is it? Which is it? There should be an accurate map for an accurate flat Earth. Gosh, I feel like I've done so much talking. I haven't even given you a chance to speak. But I want you to talk for a little while. But I mean, there's so many things to explain that sometimes I just get lost with myself. I apologize.
It's all right.
So why don't you talk for a little while? I'm tired of talking.
Yeah. So when you were showing that with the sailboat in the distance, I mean, and it looks like it's kind of going up. I mean,
all right, I found a good.
But I think with the, some people might say it's the downward refraction that's causing it to appear higher than where it is. Maybe that's what some people might claim,
The
whether it's a
downward, the
globe
downward.
earther or a flat earther or something.
So they're saying that downward refraction.
Well, I'm not saying they say that, but I'm just saying that they
Yeah.
might say that, because I'm just thinking that if you was going to try and explain that away, then they might say, well, that when you're looking over water, you're looking into more like moisture, so that it kind of has a different effect to say when you're looking over land. Because when I've looked over land, it's like if I should see that over water, then shouldn't I see that over land with distant mountains and things kind of appearing to kind of curve upwards?
Well, it's difficult to see over land because number one, like the quote unquote gravity or universal compression or whatever force, whatever label you want to use for the force that's keeping everything down, it's more uniform and accurate with water rather than with dirt. You see what I'm saying? Like, because dirt's is like hills and mountains and stuff like that. So are you talking about with like I guess I don't know which type of footage you mean over dirt. You mean like high altitude balloon footage, or are you talking about like long distance footage?
I mean, like, as in just like general stuff, really, like with
just in general, looking over
like with
dirt.
auto level footage when they show that it's dipping below the crosshairs, and you know,
Right.
I mean, I don't know how accurate it is exactly. It's just that when I saw them, and they all seem to be getting similar kind of results. So,
right. Well, okay. Here's something I want to address about that. And while this is still a huge problem, I already know how people are going to try to solve it, which still presents. See, every debunk every attempt to debunk concave Earth, I should say, is only going to lead to more answers that prove concave Earth. You see what I'm saying? For example, or that destroy another model. For example, this Skunk Bay footage. I really wish Taboo Conspiracy had taken this footage and they had sped it up to about a minute. But anyways, people with the backward. Oops, that's not the one I wanted. Here we go. All right, so this is going to show. All right, so I'm just going to pause it right here. You see where my cursor is right at the top of this mountain. Okay, so I'm just going to play this. I'm not going to move it. We'll watch that mountain move relative to my arrow. See the mountain changing and moving?
yeah.
Even right here, even this dark line right here, you can watch throughout the day. My arrow's not moving, but that you can see that whole mountain ridge is literally, it's not just the water. This isn't just like high tide and low tide. No. Look in the background. You're seeing that mountain ridge, the close one, and you're seeing this distant mountain top, the peak. All that stuff's moving up and down throughout the day. Well, we'll fast forward it over here. You know, obviously the water looks different, but look at that.
Yeah.
I mean, this is just time lapse. Of course, it's really sped up, but I mean, so that's not this. The air is changing our perception of everything, which means that optically, and so this is why I did this footage. This footage that I did here is to give evidence, not proof, evidence that water is concave. Now you can see it dipping down. You can see boats in the middle, and then you can obviously see the shoreline up here. However, once you consider this, you're like, aha, well, Josh, your optical evidence is garbage. And I would say, you're right, which means all optical evidence is garbage now, isn't it? Every bit. Whether you're using a theodolite, whether you're using a P900, a telescope, it doesn't matter because the air dictates what you see. It doesn't matter what device you have. This is the Achilles heel of flat Earth. This is what flat Earth doesn't want me to tell you, or anybody else for that matter, because once you take away the P900 out of a flat earther, what does he have left? Nothing. Because flat earth doesn't measure water. They look at it. So I'm going to look at this water and say, bullshit. I'm looking at this and declaring concavity. If flat earthers want to film water and declare flatness, fine. I'm going to film water and I'm going to declare concavity. Okay, well, some judge is going to step in the middle between us and say, well, I guess we're just going to have to take some measurements and figure out which one of you is correct. Right. And this is why flat earth is pissing their pants, is because flat earth doesn't have any measurements showing flatness. Flat earth only has measurements showing concavity. Here and here with the Lake Zagrinsky experiment. Here's another Richard Hopkins, Mr. Thrive and Survive. Here's another fraud, okay? Just one of many. So actual tangible measurements, like the plumb bob, like the Lake Zagrinsky, like this FE core, like the rectilineator from the past, all of these are experiments done in the past, but you can clearly see that the convex and flat earth community, they have to avoid tangible experiments. And so obviously tangible experiments are obviously going to prove a whole lot more than optical ones if you're actually like taking measurements.
Yeah.
Then rather than just looking at something and saying, well, is it concave? Is it flat? Is it convex? I don't know. Look at the time lapse. That we're never going to be able to get any answers if we just keep looking at shit and claiming what it is. We're never going to get anywhere, because I can look at it and claim this, and Tim Osmond can look at it and claim that, and Jaron can look at something else and claim flat, and I guess we'll all be arguing forever unless somebody actually measures something, right?
Yeah.
Unless somebody actually freaking measures something, then we're always going to be arguing, right? So all measurements that I've found, whether it be radar data or whether it be plumb bob experiments or whether it be a laser experiment where they took a third measurement point in the middle, everything indicates to concavity, and we haven't even gotten to the sun yet. And it's the sun really that disproves, again, flat and convex Earth. We can't make the solar observations the way we do unless the sun is on the inside of our Earth, like this. This is the only way it works. And furthermore, the sun we see isn't actually there. The sun we see is only an apparition, and I can prove it because I can create a sun. I can create a sun just with a piece of glass and a light. Right there. There you go. I just created another sun. All I needed was light on the other side of glass. What a coincidence. Isn't that how we see in color? So question for flat earthers, how do we see in color if the light is on this side of the glass? Shouldn't the light be passing through the glass to create color? Uh-oh. It's another massive problem for flat earth. They put their sun on the wrong side of the glass. Dumbasses. Excuse me. The sun is inside the firmament, not underneath it. Flat earthers. So there's another huge problem, is that flat earth can't explain color because they put the sun underneath the firmament instead of inside of it. The sun is shining through glass coming out of the firmament, as you can see here. So there's many, many massive and of course, the convex Earth camp, they don't even have a firmament. They just think outer space is that. They have even worse ideas. So I can appreciate flat Earth for being the stepping stone that it is. But if you're really an honest person, it should not be hard to realize that even if you don't understand the Earth is concave, that's fine. If you don't understand concave, that's fine. However, anybody with two marbles rolling around in their head somewhere should be able to understand that heliocentricity is wrong, and so is flat Earth. And if you're still undecided after that, whatever, fine. If for people, I'm not even talking to you, I'm just talking with anybody. For anybody out there who's undecided, if you can't at least get past the first two wrong models, then I don't know what to tell you.
Yeah. I was just thinking about like the Skunk Bay footage, the time lapse of Skunk Bay. I mean, it's like, would you get the same over land? Because you look over a body of water.
I would think so, because I mean, it might not be identical over land, but since it's the air that's changing, I would imagine that the air next to the lake can't be all that different from the air over the lake, right? I mean, let's say you're watching this footage and you just turn it around 180 degrees so that you're looking over, I don't know, a farm, right? So let's say there's a farm behind this camera in a field somewhere, and we look over the farm. I'm sure that the air changing over the farm is going to be almost similar to the air changing over the water. Now, of course, a field is going to have grass, right? And so grass isn't even going to reflect light the same way that water will. So even aside from the air above the grass versus the air above the water, even still, the air is going to look different because light is hitting off this reflective surface. Grass is not a reflective surface. So that might, that's another factor that plays into, what you were talking about is, yeah, it's really apples and oranges. You're right.
Yeah.
But I mean, for anyone trying to zoom across water to prove a shape, well, I have a P900. I'm an ex-flat earther, and I'm telling you, the P900 cannot prove the shape of anything. I'm sorry, it can't prove the shape of this water, because I could take this footage and say, aha, look, that whole peninsula is almost hidden by the water. And then I can just go like this and say, aha, that whole peninsula is not hidden. So here's flat earth proof right here. Look, see, it's flat. And here's convex earth proof. Look, see, it's convex. So, I mean, take your pick. You just go at a different time of day and you can prove whatever shape of the earth you want with a camera. Right, Jaron? All done. All done, flat earth, with your P900 nonsense. I just smashed it out of the park. Goodbye. Oh, you too, convex earth. Goodbye. Because the only one with tangible measurements are the concave earthers. Good luck. Yeah, I don't know if it would be the same over water or over land. Either way, the air is changing so much. I don't think it matters whether you're filming over land or over air. It's quite. I mean, the point is going to be made the same either way, whether you're measuring over land or measuring over water. The idea is to actually measure, because if you're filming over land or filming over water, you're really not proving anything. You're making an observation and then a claim based on an observation. That observation isn't made with any facts. It's just the claim is made with it's an opinion based claim.
Yeah.
It's all just opinion and timing. Really, you can just go at two different times of day and get two completely different results. So once I saw that, I was like, oh man, I'm such an idiot. I can't prove flat earth with a damn camera. What was I thinking? So once someone does that, then all these, I mean, there's tons of flat earthers without these P900s, and they act like they know it all. And then there's flat earthers with P900s. They like to act like they know it all. Well, I'm telling you, these flat earthers don't know shit. They don't, especially the ones without P900s, because they haven't been there and they haven't done it themselves. A lot of these flat earth promoters with P900s know it's concave. And some of them probably believe it's flat. I don't care either way, but I don't know. What do you got?
Yeah, I get what you're saying with because there's so many variables and it can affect what you see. So yeah, I think tangible experiment's going to be more like conclusive, really, than any kind of optical one.
Sure. I mean, yeah, because I mean, if we can put a tape measure on something and say, if I just look at something and be like, yeah, boss, that's about 8 inches, and he goes, well, I need 7 3/4. Make sure it's 7 3/4. I don't want 7.5. I don't want 8. I want 7 3/4. And I just look at it and be like, yep, 7 3/4. Here you go. He's gonna be like, get the tape measure, bro. Just measure it. 7 3/4. Just measure it and check. Right. That's common sense. I mean, I'm in the CNC machining world, right? So in CNC machining, we have tolerances where like you have like 5/1000ths of an inch, and that's a lot of tolerance. 5,000. That's a lot. That's really not tight tolerance at all. Sometimes we get prints where you get plus 1 or 2 thousandths. Sometimes we get plus or minus 5/10ths, which is 5/10,000ths of an inch. So that's how much tolerance we have. And if you screw it up, you throw the part in the trash and you can't use it, and we lose money. So in the machining world, checking your parts is very, very important because they all look identical. They all look the same, but you actually got to check them. you gotta check these parts, because if you don't check them, then I can't prove. And when we ship the parts, right? When we ship the parts and the customers get their parts and they get them out of the box, you know damn well that if your tolerance is only 5/10,000ths, you take an inch and you divide it up 10,000 times, and my tolerance is 5 of those 10,000ths, then you know that when they're gonna throw some mics on those parts and they're gonna check them, and if there's anything that's wrong, they're gonna ship the whole. If they find 1 out of 300, they're shipping you all 300 back, and you're gonna have to freaking remake them all. So I know, as a flat earther, as a machinist, I was a fool to be a flat earther, and I think Brian Mullen has come to the same exact understanding that he was a fool to believe the Earth was flat, because he didn't actually take any measurements. And so this is this is a place in Spain, obviously, and this was brought to my attention that this is a place where there's all kinds of waterways. Each one of these, this is a street, actually, I figured out. Each one of these little canals here is a waterway. And one of the best experiments that concavers have come up with, as far as tangible experiments, is to run fishing line. What you do is you find fishing line that's the same exact density as the water. Because if your fishing line's too dense, it'll sink in the water. If it's not dense enough, it'll be too buoyant and it'll rise. So if you find fishing line that's the same exact density as the water, so it doesn't rise or lower, so the line's not going to sag or go up, and you run a line underneath the surface of the water, from one side to the other, and you tighten that fishing line, and you've got the altitude at the same altitude on both sides of one of these canals here. And then you can take measurement points along the middle, maybe 3 or 4 different measurement points along the middle of that body of water. And you can determine if the surface of the water is parallel with the fishing line. If it is, then water's flat. And so this is a great experiment to determine the shape of water. And so that's something that I'd like to do. However, finding long, shallow bodies of conducting that, the concept of that experiment is extremely simple. You're like, oh, that's a great idea. Yeah, just find water and the fishing line, same density, string it across, measure it, bang, done deal, right? And then you actually try to do it, and you're like, all right, where the hell am I going to do that? What body of water can I find? Wait a minute. That's a really simple ass idea, but when you actually try to get it done, you're like, where the hell am I going to find a correct body of water for that? And so Ruben pointed out a place here in Spain where they have. So people, if you live in Spain, please go do this. I don't know. I mean, maybe I should research a little better. Maybe I could find a place here in the United States. I'm sure. But I mean, this is a simple idea. You just run some fishing line across a body of water, and then you can get tangible measurements. But it's still the concept is simple, but it's the task is still difficult to get that done. But you don't hear flat earthers talking about anything of the sort, and so that's something I wanted to
I thought it was something that I think something that Jaron brought up, something about the was it the foot, what was it, so like the Forrester line type of experiment, what was it called, with the fishing line to see if it shown any hump.
That one was the torque the line. I'll show you that.
Yeah,
one.
torque the line, that was it. Yeah.
Yeah.
Isn't that the same kind of thing that you were?
Yes. And now this gentleman here promoting, okay, globe busters, torque the line. It is a difficult. I don't blame them for feeling it. No problem there. All right. So yeah, I guess I'll just play this. The channel itself.
Hey,
yeah.
it's Mitchell from Australia.
Here we go.
Black versus Globe has been.
Okay, yeah. So this is it here. Now he went through. I watched all these videos, and he went through the spectra line. Right. He went through several. He went through several attempts at trying to find a line that was strong enough. See, what he did is he was rating the tension on the fishing line itself. And what he found was that this particular fishing line wouldn't hold up to the strength that was claimed by Spectra. And so for that reason, he wasn't able to get the experiment done. I don't know. I'm not really sure. I'm not sure why he just didn't run the fishing line across the body of water anyway, negating the tension just to see what he got. I don't know. Further, aside from that, this gentleman has done more than I have, so I'm not going to criticize. But this is where folks can go and watch these videos so they can understand the concept and they can understand the materials needed, the understanding that's needed, and so on and so forth. And they can realize how difficult this actually is to accomplish, even though the concept is incredibly simple. So can you elaborate more? I wasn't aware that Jaron. Yeah, tell me what you know.
I thought it was really the first place I heard it, because when I used to watch those sort of channels like Globe Busters and all that, and
yeah, Jaron leaves lots of clues. You know what I mean? He leaves clues. It's whatever.
Yeah, you sound a bit like Pete Shea. He leaves clues everywhere.
He does. Well, Mark and Eric. I mean, Mark and Eric leave the most, but I would say that Jaron and Bob kind of leave. They're next in line. What Jaron did with his when he was explaining our the personal perspective bubble, if you will, our Truman Show dome, that's the result of our viewability range and how limited it is. That was one of the biggest concave Earth clues that Jaron ever gave, because he pretty much showed this right here, what I'm about to show you in a second. Right here, and then that's already muted. Okay, so Jaron basically gave a huge clue away, which I appreciate. If I can just find it real quick. Which should lead to the star trails and all that other stuff. What the heck? Where is it? Oh, I think it's a 6-minute video. I didn't go for. Aha! Here we go. This one. Well, there's this one, but there's also this one. Here we go. So some people would say, well, if the Earth were concave, then we should be able to see from one side all the way to the other. And it's like, no, that doesn't even make any sense. First of all, there's all those layers of glass in the way, starting at 62 miles over your head. But when Jaron was explaining the personal perspective and how the lights move across the sky versus how we see them based on the ground, he was giving away a huge clue that any eye, whether it's a camera or a flash or whatever, is only going to be able to see so far. So you're only going to be able to see so far in any given direction. And so your view of the sky is only going to be, or your view of anything, like your human eye can't see 100 miles away. You know what I mean? It's limited. We have a limited viewability range. And so this is what we're going to see. We're going to see stuff like this, based on your position on the earth. This is how our eyes are going to view things. See, for this observer, the sun's moving across his sky like this. So it's going to rise over here. It's going to move across the sky, and it's going to set over here. That doesn't mean that's what the actual sun is doing. That just means that's how this observer is going to see it based on his location on the Earth's surface. Just like that. And so this video is very similar. Where'd it go? There we go. So this is another huge problem for flat Earth. At least the spherical Earth people can understand the stars. Now, people always like to say, well, you can't tell the shape of the Earth by looking at the sky. That's true. But we know it's not flat by looking at the sky. It's either concave or convex, because these observations can't be made on a flat plane, just like the maps. There's no maps. There's no flat maps that work. There's no flat stars that work either. You know what I mean? It just there's no way around it. Like, you can do all the smoke and mirrors. Flat Earth has had way too long to produce a map and stars. But for thousands of years, we knew it was flat. Come on, this is stupid. There should have been enough time, right? Remember when Kent Hovind was talking about Haeckel's drawings and how he was proven a fraud by his own university? And he said, well, it's only been 125 years. I know it takes time to get books updated, but 125 years ought to be enough time, don't you think? Well, I agree with Kent Hovind. I think 125 years is way too much time to get these books updated. And thousands of years is plenty of time to get an accurate map.
Yeah.
Right?
Huh.
Call me a cult member if you want to, but I make sense, So this matches our observations. Go ahead.
Yeah, just that personal atmospheric dome, and I've looked at that. I'm like, well, even they're saying that light's bending up, so that it's to give you the apparent position of the sun, where you'll see it at the horizon, even though it's some other angle. It's well above the horizon somewhere, and it's bending at such an angle to make it appear that within your visible bubble, dome thing. But yeah, I don't know. I'm like, well, the upward bending of the light, and that I just keep getting stuck on that. Like how it's. But you're saying about the what is it? You were saying about the black goo or something, like the.
Oh, right. Yeah. Well, whatever's. I mean, whatever. I mean, that was just like a. That was
just a
kind of thing. Yeah, like whatever is actually in that celestial sphere. Like whatever the ether or whatever. Like there might be stuff in heaven that we don't have here on Earth. So, there might be things that operate in this world that we might not always have the answers to, and you'll hear flat earthers saying that way more often than you will a concaver. That's for damn sure. That's something I had to say a lot as a flat earther. Well, we don't really have that figured out yet, but we know it's flat. We know it's not. There's no downwards curvature. We know we're not spinning and all these other things. Well, concavers do have things that we don't know, but it's not as bad as the flat earthers, man, they don't know shit. They really don't. They really don't know much.
Yeah, I was just.
I would know. I was one of them.
Yeah.
But like here's, well, let's see where if I can find. Right. See, in this model, the light it's bending down and bending back up. See, that's the problem. See, the convex Earth tells you that refraction is happening downwards, which is true. Light is from eye level. Light our line of sight does descend slightly, and I'll explain what I mean. Okay, here we go. Okay, so this bottom one, this is if light is not bending. And this is a demonstration of light bending upward. Now you can see his line of sight. It does go towards the ground or towards the water. So his line of sight does go down before it goes up again. So people are saying, oh, light's bending down. No, it's bending up. It's both.
Well, it's bending.
It's still
What would
bending in the
be trying
same
to bend upwards is what I'm.
Ultimately, it's bending upwards, yeah. But it's going to go down before it goes up. Your line of sight is going to go downwards. Not a downwards curve. It's still an upwards curve, but you can see you can understand what I'm saying in the diagram. It's still curving up in a sense, but it's always going to curve like this, and that's where shit gets hidden. That right here is where convex earthers are taking footage and saying, "Aha! It's hidden by the curve. It's hidden by the downwards curve." They're finding spots right in here where they can hide shit, and right over here where they can hide shit. And the further we can zoom, the further. If I zoom now, I'm going to change my horizon up and put my horizon over here, right? Because I zoom, I get a more distant horizon now. I can see further, so my horizon is increased over here. And
I thought the horizon was at a set distance
too.
though, and you couldn't like go zoom, to see more of the water. I thought there was like
there's
cut
only
off that you.
I'm sorry.
Like there always seems to be a cut off, and when you try and zoom in more and more, and you can't see any more horizon, it just kind of. That's where the end of the visibility of the surface is.
Right, kind of like I've got a great example of that actually. My recent appearance of here's another thing I want to smash out of the park. Jake Gibson, you said that you've never seen the sun shrink into a little dot. You've only seen that in YouTube videos. You've never seen it in real life. And because you'll be watching a YouTube video when you watch this, you still won't have the proof. However, I was there here, and I am here to tell you that the appearance of the sun does change size. Because I know this is a little blurry, but you can tell that you can see the size of the sun there. Nothing crazy to see here.
Yeah,
but
it's just I keep hearing this a lot from flat earthers that the sun does change size, and then some say that it doesn't change size, or at least not horizontally, and that's due to atmospheric lensing or whatever. And basically, if you used a solar filter, you'd see it kind of stay in that size that some people say,
Right. So this is one where everybody's right. Like, obviously, any object that moves away from you is going to appear smaller and smaller, right?
Right.
So that's all it is. It's as simple as that.
Yeah, I know, but I'm just saying, like, if you use a solar filter, apparently well, when you see it coming further up, it would be getting more like glare or something, like that's causing it to appear bigger than what it is, and then so as it goes further away, there's less glare because it's going into kind of it's getting more dull. There's less light coming, so it's not kind of
It takes the the
Causing all the
filter's going to
glow.
take away the glow. It's going to take away the brightness, and you're just going to see the shape of the sun for what it is. I think I know what you're saying. And so I'll touch back on that in the next piece of footage. But what I wanted to show you here was that you were talking about how you zoom out so far you can't really see anymore, and this is what you're talking about right here. So
Yeah.
like this is max zoom, and it appears like this is just a cutoff. And you can clearly see this water's ramping up, man. But I'm just gonna play this real quick. Most of this video doesn't even have anything to do with the title, except for like right at the beginning where I show the two different sun sizes or appearance. They're just appearances of that's not the actual sun, anyways. So there is an actual sun, but it's on the other side of the glass. Every time we see the sun, it's just an appearance of the sun. And so that's why this argument's going to exist forever. Does the sun shrink? Does it not? Well, you're just seeing an appearance of the sun, so it's not going to, there's really no argument there. You're just seeing an apparition. You're not even seeing the actual sun.
Yeah.
And that's kind of the point I made with my flat Earth sun crush video is that if you have, let's say you have a sun, right, that you zoom in and you can see the sun right there in the clouds, right? I think I might even have some of that. I think it's this one. Yeah. I'm gonna play this piece of footage just to show that you can, in fact, all right, so we've all seen the sun like right there in the clouds, right? And then you slap a solar filter and it doesn't look like the sun's in the clouds, but obviously that was a very close light source, right? No argument there. We all agree, flat, concave, we all agree the sun's close, right? Close light source, not 93 million miles away, right? Okay, so we see the sun in the clouds without a filter, right? But then from the high altitude balloon footage, we see this. It's like, wait a minute. How is the sun way down there in the clouds and way up here with the balloon? Not only that, but that same observation can be made from the west coast of the United States at the same time as the east coast, and it can be made in the northern hemisphere as in the southern hemisphere. So how is it? Where is the actual sun then? Is the sun 1 mile up at the clouds over Boston? Or is it 1 mile up in the clouds over LA? Or is it 1 mile up in the clouds over Mexico City? Or is it 20 miles up in the clouds over Boston? Is it 20 miles up in the air with the balloon over LA? Is it 20 miles up in the air over Mexico City? And then you start realizing, wait a minute, no one's actually seeing the actual sun. We're all just seeing apparitions of it. The sun appears close to you no matter where you are. The sun's always going to look like it's close to you. This isn't the actual sun. The sun is not there. You're just seeing it there. And that's easily provable because the sun can't be 20 miles over Boston while at the same time it's 20 miles over LA. That's impossible. That's not even a logical, rational statement. It's like really dumb to say that. You know what I mean? And that's what Flat Earth is trying to convince people of, is that the sun is everywhere all at the same time. No, the sun is everywhere all at the same time because the Earth is concave and the light's coming from the center. See, in this video, I show how close the sun. Well, not me. This is somebody else's footage, but in this video, I talk about how you can see the sun descending here. Actually, I'm gonna
look at that.
I'm gonna show you how much of an asshole I am.
How can flat earthers actually believe that's the actual sun right there, like 500 yards above the Earth? That's stupid.
And I admit I was stupid for believing it too. So I'm just being fair.
Come on, the sun is actually not actually right there. How would half the Earth have sunlight if the sun was actually that close to the Earth? Look how close to the Earth that sun is. It's obviously just an apparition. That's where the sun is seen by this camera. At eye level, mind you. The sun is at eye level as well as the horizon. Very interesting, isn't it?
Poncho Pete says, Josh, there ain't no bendy water. Poncho, you missed the beginning of the show. I was talking about
sliding down your perspective bubble. Look at that. The sun's just descending just like that. No way. That's obviously
Concave Pete. That does have a nice ring to it. Hey, what's up, Sean?
Actually falling to the earth. Look at that. It looks like the sun's about to crash into the earth. Oh no.
I can be such a prick at times. No, but seriously, obviously the sun's not actually that close. We need to rethink everything, and we need to really consider like what is this sun that we're seeing? Because I mean, there's all kinds of photos. Like you can even look at all these photos, like the sun halos, right? So look at this image, and you see that sides of the north, the four sides. You know, the as above, so below. And here's your dollar bill. Here's the light source coming out of your dollar bill, the American dollar. So we've got all these images here. We're seeing this diamond-shaped glow. Here, you see it here. You see it here. We can see it here. This is really interesting. Oh, it went small. I hate that. Why doesn't it blow it up? But here, you can see this one here. This is a distinct diamond shape right in here. And we're clearly seeing we're clearly seeing what looks like glass and water. I mean, this is what glass and water looks like. Flat earthers agree. They think this is representative of see, they see glass in the sky and they're like, aha, a dome over a flat earth. No. You're looking at light and glass and water. None of that proves the shape. No, this doesn't prove flat earth. In fact, flat earth can't explain why they're seeing a diamond shape in the sun. There, or here, or here. Where's this diamond shape coming from, ladies and gentlemen? Nobody cares to explain that. That's why the sky is blue. That's why we have rainbow. This is really important to understand. Flat earthers think the sky is blue because there's water above the firmament. I use that argument. I was wrong. It's not a bad argument for a child to use against an adult, but so this is why there's birefringence of the glass sky. That's why we get two moons and two rainbows. And so we would not see in color if light was on this side of the glass, flat earthers. You need the light to pass through the glass to create the light. Oh my. Where was so these sundogs, these sun halos that have this diamond shaped, convex, once again, convex and flat earth can't explain that. What this diamond shape is, and this is obviously, this really looks like an octahedron inside the celestial sphere with another spherical layer of glass around it. And when you look at what these shapes of this glass, like you have light and glass and water up in the sky. And so there's very wise people who have started playing around with light and glass and water just to see, what they can come up with. Very, very smart individuals like this guy over here. And what he's finding is that he can play around with light and water and glass, and he can reproduce what we're seeing in the sky. And if I could find it, that'd be great. I'm looking for a specific. Where the heck is it? Aha, here it is. There we go. So what we see in the sky is a lot of times what we see right here. We're seeing light coming through water and glass. And with regards to the sun dogs, where you have this is, I don't know if you've ever, Jamie, are you aware of what the Seymour radar is? Have you heard of that?
No,
The Seymour? Okay.
no.
It's called Seymour, CMOR. It's Canadian Meteor Orbital Radar. And you can here, I'll just do that. Seymour mapping. Okay. What it is they've taken radar imagery of the sky, and of course they have to explain it, through a heliocentric model. And so what I want to do is I want to play just a real quick video about that.
Back to the Canadian.
And it's going to show that they're able to look into the sky, and they're able to detect this octahedron that some people say is, oh, that's crazy. There's no evidence of that. Okay, well, there is. We're seeing the sundogs right here. The images of the sundogs that I showed you. Let me go back here. So look at this. So you see this octahedron light source inside of a sphere, okay? And then so you see this too. Okay, so this is what the concavers propose. And then we see images like this, like actual images in the sky showing us like, okay, like there's obviously, so you see this on one side, what Steve calls the helion and the anti-helion, or some people would call it the the perihelion. Like right here, you have the perihelion here, and then you have, I don't even know all these different terms. I'm just saying the circumzenith arc. Now, zenith is straight up above. That's what zenith means, looking straight up. If you have the sun straight up above you, like literally directly over your head, and you're looking straight up, 90 degrees up into the sky at the sun, that's where light is going to bend the least, is when the sun is directly over you and you're looking straight up at it. That's where light is bending the least, which makes sense. If the sun's beside you and you're looking at the side, near the side of it, of course, it's going to bend more. Anyway, circumzenithal arc. So here, anyways, you see perihelion, which is, it calls it the sundog right here. You see the two different sides of it, and then the top. Well, wouldn't you know it, these folks in Canada, I'm just going to play it.
Back to the Canadian Meteor Radar, Seymour. What they totally missed it. I think this image that they're producing with their radar imagery is indicative of.
How can you say flatties don't know anything? Well, because they don't. I mean, all right, you're right. I'm sorry. I was wrong. I was wrong to say flat earthers don't know anything. They don't know much. How about that? Flat earthers don't know much. However, I wouldn't know what I knew today if it wasn't for flat earth. So flat earthers know something. All right.
Okay. It's quite plain. This image that they're producing with their radar imagery is indicative of sporadic meteoroids. Okay. It's quite plain to see. This is just, it's radar imagery of the octahedron in the middle of the concave, along with the celestial sphere. And then it has these hot points.
The whole sundog circuits. Yes, eminent. I'll show that in a second.
They call this one the helion and the anti-helion, and this one the toroidal. But what they did is actually they went through the whole year. So you have the 5th day of the year, the 15th day of the year, all the way up to the 355th day of the year, meaning that 365. I'm not sure why I don't think they have 365, but I guess they went by 5s. So what I did was I brought it in Photoshop, and I did a little animated GIF of it. I'll play that for you right now. Play. There we go. Now look what we have here. You see the north apex of the octahedron pretty much stays visible throughout the whole year. However, the south one only becomes visible during part of the year, i.e., when the sun goes south in the wintertime. And so we're getting a preference of warmth or activity more in the northern side.
I made some errors in my videos, and I have to go back and correct those errors.
Yeah, so that video ended quite abruptly. This is very important. All right. This is very important for flat earthers to understand. If you don't know what happened with Brian Mullen and why he isn't involved in the flat earth community anymore, this should give you a whopping, massive, huge, monstrous clue as to why. And this is just a 2-minute video. Just let me play this, and we'll move on to another whatever topic you want to discuss, Jamie. But let me play this for the audience real quick, because this guy is very credible. He's not a dumb guy, very bright individual, and he knows what he's talking about, and we should listen to him.
In my videos, and I have to go back and correct those errors. I made some errors in my videos, and I have to go back and correct those errors. In the words of the great John F. Kennedy, an error does not become a mistake until we refuse to correct it. So I will correct some of those errors. However, I don't think that anything I've done in my videos is absolutely wrong. I need to fix some things. But anyway, my last video was released at the end of September. I released it at the end of September. And then I did a radio interview on Flat Earth and Other Hot Potatoes. And I was going to keep going with my series, but then, well, had a wrench thrown in my gears. Very wise retired surveyor, 32 years, contacted me at work. He saw my videos and figured out where I worked and gave me a call. We discussed an experiment that he deemed the plumbicular experiment about using lasers, and came up with a way that we could actually try to measure the curvature to prove this. And shortly after that, he sent me a link to the rectilineator documentary, which is actually the backbone of concave Earth theory. Concave Earth basically is the theory that we do live in a sphere. In a sphere, we're on the inside of the sphere, and that the Earth curves up away from us. And we just can't see the curve because of an optical illusion. We do live in a sphere. In a sphere, we're on the inside of the sphere, and that the Earth curves up away from us.
All right, did you catch that?
Here we have.
So that's that. I mean, once you see that and you're like, oh, okay, Brian Mullen was researching concave. Oh, wow, how stupid is it now? And poof, he's been gone for 2 years. Well, look what's happened in the past 2 years.
In my videos, and I have to go back.
There's several of us that have been stopping huge mud holes in flat Earth, and for good reason. So let's hear you talk now. Please.
Yeah, talking about like Brian Mullen, wasn't he like one of the people that was originally behind the FEIC, and then he actually backed out of it, and then it completely disappeared. And
right,
yeah,
and obviously, you know, I know why. I mean, I've never talked to them. I can't say I mean, there could be other things going on in his personal life. You know what I'm saying? Like, I'm not claiming to know for sure. I asked lots of questions. I bugged lots of people trying to figure out what happened to Brian Mullen, because it didn't make any sense. Here's an engineer that just left flat Earth. Why? Did he find downwards curvature? No.
well, supposedly he was being so it happened that there was this guy called George Natiok or whatever he's called, that some globe believer, and he apparently was the reason that he lost his job or something. I don't know. I've heard this stuff on some channels. Yeah.
Yeah, I mean, the flat Earth community, if Brian Mullen left because of concave Earth, it's not like the flat Earth community is going to tell you that. So there's going to be all kinds of I mean, if that's the real reason, then there's going to be all kinds of wrong, false explanations for his departure.
So you're saying that George guy could have been like the one who was the Glober could have maybe been like.
I have no idea. I never heard of that guy till you just said it.
Because he apparently was the reason that he lost his job or something, and then he basically at that point went like missing. I don't know.
Yeah, I don't like. I've never heard of that
heard.
guy, and I don't know any of the details. I don't know Brian. It just seems clear to me that as soon as he did, like, if you look, let's see. Here we go. I'll look at his whole. When we look at his whole playlist, right? His whole balls out physics playlist. You'll notice that the Force the Line was one of the last ones. And then we just haven't seen him anymore.
So when was that put out then?
This video is actually late 2016. We don't know for sure. This is the date it was mirrored by Seventh Day.
Yeah. Well, it actually said it was originally in late 2015.
Yeah, right. That's what it says here. So if you use this link, you'll run into that. So we don't know when the original. This is probably true. This is probably accurate. I don't see why they would lie. I mean, it was mirrored December 31st, over a year, just over a year after Brian originally. So I think this is accurate. I started looking into flat Earth mid to late 2015 myself. I really don't have any excuse for being a flat earther so long, to be honest with you. I'll tell you right now, while it's not an excuse, the reason I was a flat earther so long is because I was hold on. Hey Ernie, I love you. I'll call you back. I'm doing a live stream, all right? All right, bye. The reason I was a flat earther so long is because I was too focused on getting out there and reaching the people. Unfortunately, I went out there and I don't take it back. I'm glad I did. I'm glad I did activism. I'm glad I did the shirts, the business cards, and get out there and talking with people and doing the meetups and just all that stuff. I'm still glad I did it, even though I was promoting a false flat earth model. I'm still glad I did it because I'm sure I led a lot of people to the truth, but it was my mistake. I went out there and shot my mouth off without knowing what I was talking about fully. And this is what I mean, Pacho Pete, when I say flat earthers don't know anything. Because the earth is spherical and I was promoting a flat earth. However, I was still right about a lot of things. There's no downwards curve. Outer space is a hoax. The lights are close, blah, blah, blah. You know. So I was responding to a comment that Poncho Pete made in the chat not too long ago.
Hi, I'm Brian.
So in this video, he explains, the whole concept of basically building a straight line and then comparing it with the surface of the water, which is a very difficult thing to accomplish, to even build it. In fact, Steve tried. Stephen Christopher, also known as LSC, Lord Stephen Christ, he tried, but he was using aluminum, and I don't think aluminum is strong enough for that. Aluminum's too bendy, warpy, stuff like that. It's the rectilinear is very tough to accomplish. There's other practical experiments like the plumb bob or the fishing line that can give us better answers. So tell me your thoughts.
Yeah. Yeah, I don't know. It's
Once you hear Brian Mullen telling you that, I mean, that's a powerful testimony, what we just heard, right? I mean, he's telling us that an engineer of 32 years, a land surveyor, called him up and told him to research concave Earth, and then poof, he's gone. You know, like, okay, he's basically telling us, hey, I mean, he's kind of saying it without saying it, right? I mean, he told us research concave Earth, and he peaced out. He's like, peace, I'm out of here. A land surveyor of 30 years called me up on the phone, told me to research concave Earth. So we live on the inside of the globe. The curve goes up. Bye. We haven't heard from him since. You know what I mean? Like, okay.
Yeah,
I'm
yeah,
kind
but
of
I thought it
fool
was
for not listening
still.
earlier. I had never watched. But that's right at the end of the video. I had never seen the exact end of that video. If I had, man, I might have snapped out of this whole flat thing a lot sooner. You know.
Yeah, it's just like I thought it was kind of still around up to like early 2017 because he was still around for the, you know, when they'd announced the conference. I think he even went on Globebusters, if I remember, and then they sort of, and then he backed out of it supposedly, and you know, like it disappeared. So
Yeah, he probably watched enough of LSC's material, and of course, you know, most people, they're not going to want to, you know, this concave Earth truth, you know, in modern day is now directly attached with, you know, this Lord Stephen Christ being God and the mark of the beast and so on and so forth. And whether or not that's true, that's beside the point. Whether or not it's true, it does push people away. People think, oh, that's the guy that calls himself Jesus. I don't want to hear none of that. I don't. That guy's crazy. I don't. Why should I listen to him for? Well, you should listen to him because he might be right about he might be wrong about being God, but he might be right about being the Earth being concave. And so for that reason, I listened to what he had about the Earth being concave, and it's the concave Earth model is the best model of the universe that I've ever seen. Period. And for people to, I mean, an honest researcher is going to know that. Someone who doesn't research enough isn't an honest researcher. Someone who cherry picks information isn't an honest researcher. An honest researcher is going to listen to not just Steve, but listen to the other concave earthers as well. It's obvious that the Earth is concave. You know what I mean? It's so obvious, and it's so obvious that now you're starting to hear flat earthers talk about the dip that's in the middle, and now Patricia's gone and Brian Mullen's gone, and what's going on? We got lots of flat earthers jumping ship over to concave. I mean, it's happening fast now. It's happening faster and faster and faster, and so really, I mean, all the flat earthers are getting left in the dust.
well, you talk about the Patricia thing because I've been like watching some of Antonio's stream, and apparently, like, she's just, you know, like, because the official thing about it is that she left because she couldn't deal with all the hate coming from flat earthers or something, because some of them were, you know, calling her this, that, and the other, and
Yeah.
but then some are saying now that, you know, that, well, she was kind of declining in views and things like that, and subs weren't really going up very quick, and so she's kind of, you know, it's a kind of tactical thing to kind of disappear, and then maybe she'll get kind of repackaged at some point, and then so there's all kind of different theories on what could be going on, but yeah, I don't know. I mean, yeah, it's like who's real and who isn't. You know, what's their intentions? It's, you know, I mean, these people who, you know, think it's flat, and it's like, well, are these people really, you know, like Patricia and Mark, are these people really after the truth, or are they, you know, are they just, well, you know, either they put in place, or are they, just trying to make money, or what? Because we see that they get into the media a lot, and these are always the two that are picked most of the time, along with Globebusters and
Dave Murphy and certain others. Yeah, Eric.
like Dave Weiss and all them people.
Mm-hmm.
Yeah. So it's interesting,
the whole Metatron thing. What was going on with Mark and Patricia. I don't know any of those details, and I'm not going to claim to know anything. I will say this. What I will say that I'm almost one thing I am certain of is that Patricia Steer is an intelligent woman. There's no way she could keep her cool and be so calm and sweet for that long, with all the hate being thrown her way. So huge credit to Patricia Steer for that. Number one. Number two, I don't know if I can prove that she's necessarily hiding concave Earth, or if she knows that she's promoting a false model. Certainly, there's people that would advocate for the pro and for and against. So I don't have any facts, so I can't prove any of that. Number three, while not having any tangible evidence for myself, it's my strong opinion that Patricia Steer is a female. There real transgender people exist, but there really is a transgender movement that's being fueled that I don't think is totally honest. Not everyone that's accused of being a transsexual is one, and I don't have any knowledge, but it's my opinion that Patricia Steer is a woman, and people really ought to rethink all these claims, because there's lots of people getting accused of being trannies that just aren't. You know what I mean? There's certain things that have truth, and then the media and social media like to embellish those truths just to get people in a trap. You know what I mean? So just want to reach out and say, hey, I love you, Patricia. No hard feelings. I do think I do think you had some involvement. I don't think Mark and Patricia's involvement in this movement was totally grassroots, totally pure. But I don't have any knowledge or details or beyond that, so it's tough for me to really judge. What I do know is that Mark is both hiding concave and leaving clues towards it. So is Eric. So are almost all of them. I'm not trying to single anybody out, but in order to successfully hide the concave Earth using flat earthers, you're going to have to inform each gatekeeper which bullet points they cannot talk about. For example, if you're going to hide concave Earth, you can't be having flat earthers talk about plumb bob divergence. You can't be having flat earthers talk about the Kármán line barrier that's at 100 kilometers. You can't be having flat earthers talking about taking 3 measurement points along the surface of water. You can't be having flat earthers talking about diamagnetic water. You can't be having flat earthers talk about this and talk about that. There's some things you just can't talk about if you're trying to hide something, right?
Yeah.
If you just robbed a bank, you don't want to be walking down the street with freaking dollar bills falling out of your pockets, right? You don't want to. If you just ate all the cookies, you don't want like chocolate smeared on the side of your face with crumbs stuck to your teeth and shit. You know what I mean? Like, it's going to be obvious you just ate the cookies, right? Well, you can't have Mark Sargent and Eric Dubé talking about plumb bob experiments. Why? Because they're not there to provide you with the truth. They're there to provide you with the journey. I'll say that again. Mark Sargent and Eric Dubé are not there to provide you with the truth. They are there to provide you with your journey. And that makes more sense. Because I know they both know it's concave based on things they say. I mean, I even made a little little quick video. It's called what channel am I on right now? The Flat Pool one? Okay, so it should be called Eric Dubay and the Flat Earth Starball. Oops. So I made just like this one little video. Actually, I use some of Dubay's work a lot. Here, let's see, where is it? How far back is it? Here we go. In his 200 proofs, he actually ends up showing you a piece of art.
He's showing you all my understanding. This word. Visible truth must be ignored because this theory stands in the way and prevents its votaries from my understanding. 149. Throughout thousands of years, the same constellations have remained fixed in their same patterns. Look at that moving out of.
He's showing you all the stars, ladies and
Earth
gentlemen.
were a big ball spinning around a bigger sun, spinning around a bigger galaxy, shooting off from the biggest bang as NASA claims. It is impossible that the constellations would remain.
So Eric Dubay is showing you the celestial sphere. That's pretty interesting. Not only that, but one of my favorite videos that I've ever done is this one.
300 foot tall.
I took Eric Dubay's 200 proofs. And what I did is, I didn't even link it. I probably should have, but I didn't bother because everybody knows Eric Dubay and the 200 proofs, so I didn't bother linking it. So what I did is I took his 200 proofs and I wanted to see if any of them would work or if any wouldn't work in the concave Earth model. And I found one claim. I found one of the 200 claims that would not work in a concave Earth model. And that claim, if true, would debunk it would be evidence against the concave Earth model. I'll say that. And the claim was that the navigating over water always works better with plane sailing, plane trigonometry, rather than spherical trigonometry. Okay. Now, if that's true, that would be evidence against the concave Earth model. However, where is the evidence that plane trigonometry is actually more accurate than spherical trigonometry? Because
I've heard it.
That's what flat Earth actually is flat Earth is trying to figure out everything on a flat plane. And as it turns out, spherical trigonometry is better than flat Earth trigonometry. So it appears that claim wasn't even true. So I've found that all 200 work. So I made this 200 proofs concave Earth is not a spinning ball, because that's the one argument that I get the most when I tell people that Earth is concave, not convex or flat. Then I get all these retarded flat earthers talking to me, but yelling at me about axial rotation and orbiting around the sun and all this spinning and movements. And it's like, that's why I say flat earthers don't know anything, because they don't even know that concave Earth is a stationary Earth model. And I get all this spam from all these retarded little flat earthers telling me that the Earth isn't spinning. And I'm like, I know. I know. And I get it too, because I was that new. I was that young. I was that wet behind the ears. I was that vicious little flat troll trying to tell everybody my truth about flat Earth, I I get it. I was one of those flat Earth idiots. In fact, I could prove I was one of those. I could prove it. I can prove I was dumb. You're not going to hear people say that too often, but I will. I can prove to you that I was dumb. So what are your thoughts, Jamie? Talk to me.
Yeah. So yeah, about that plain sailing thing, it just seems like an assertion to me. It's like when people say water's always flat and level, and it's like unless you've actually gone out and tested it over a large enough distance to see if there's any curvature in it, because looking at a pool of water or something isn't gonna really tell you if there's any discernible amount of curvature in it.
Right.
So there's like people make these kind of assertions about things and they don't actually go out and test them. So, well, I haven't really tested a lot of these things myself, so
Sure.
I can't really say for sure on a lot of it.
But what you can do is admit, like I did, what you can do is admit that maybe some of my beliefs were a little bit too hasty because I didn't do the testing, right?
Yeah, like it.
So like I haven't done
This
the
thing sounds
I haven't done the
right.
plumb bob, I haven't done a rectilinear, so I haven't, I haven't proven these things to myself either. But what I can do is say I was wrong to say I knew it was flat. I did not know it was flat. I definitely believed it was flat, but I was wrong to, and that might be something along the lines of what you're saying.
Yeah, well, I kind of was never in the kind of stance that I knew it was flat, because I was thinking, well, maybe it's just not the size that we're told, and
Right.
it's some other shape or whatever. And
well, I said I knew it was flat, and I was wrong. I'll speak for myself, but continue.
Yeah, but I was more of like, it's not, this like spinning ball, like the, and I, thought, well, concave, well, how does that was, there's things like that I couldn't get at the time, probably because I hadn't even really looked into it that much. But I mean, there's still things that I'm kind of like I said with the light and stuff. Maybe there's a way that it could be possible. I mean, you talk about like the ether or whatever, that is perhaps it can be, like have an effect on it. Like if that that the ether, because people that talk about dark matter, don't they? This mysterious like
code
dark
word,
matter and dark energy that that makes up
black goo,
95% of the universe.
Right, black holes and black goo and stuff like that. Yep.
So yeah, so that could be like what like, because yeah, so they have to like come up with these theories like to make the model even kind of make any sense, but as of yet, I don't think they've really substantiated the claims with the dark matter and dark energy. It's I think it just kind of feeds into people's kind of like, because it sounds mysterious, doesn't it? Like kind of
black
like with aliens and things like that. And
yeah, it's got a nice appeal, like it's got a, it's spooky. Yeah. It's
yeah.
spooky. There's two things I wanted to talk about. One, well, maybe I'll do that first. There's a portion of a video that I want to play. Oops, here we go. I'll get my shit together here. Here we go. All right, cool. So
there are hundreds of antique maps of practically all nationalities made with this specific projection. We would expect to find a lot of information on it. But Wikipedia leads to dead end after dead end.
Okay. So
Some of the most significant videos and articles relating to concave Earth tend to disappear.
So this right here, like I mentioned before, this is just a mirror. This is actually this is episode 1 of his cave series. This channel right here, Rethink Everything. This is one of the best concave Earth documentaries ever made. At this length, at this, relatively 37 minutes, at this length, this is one of the best eye openers. And so I'm going to skip forward to here in the video. This is an incredible short little documentary. But I'm going to skip. He actually included some of my work in here, and I'm very honored and thankful for that. He threw in some of my 2 cents that I had done with some of the historical written work, i.e., Bibles, where it talks about heaven being inside the earth in the center. But what I really wanted to get to was here: the magnetism, the gravity, etc. The force, the force that's causing everything to cling to the earth. What is this force? So I'm going to let Tyler explain this real quick.
Just something to take note of. But for all those people that want to say that Scripture does not say that heaven is in the earth, well, you just got proved wrong.
So, real quick, the black sun is the celestial sphere. It's just 2 different terms. There's much ado about the terminology and whether the black sun is an occult term or, I assert that the black sun is a term that's been used to hide the reality of the celestial sphere. And so even the term Saturn, Saturn has been renamed a planet. The original Saturn was the celestial sphere as well, the black sun. So I just wanted to point that out just for shits and giggles. Here we go.
This black spot right here is where the light has disappeared. It cannot penetrate this spot, nor can it exist here, because this is the point of centripetal convergence, where light is literally sucking down like a drain down a hole. Okay?
There's no inside structure. Is it all? Yeah, there's only a surface. There's nothing inside. Is the sun actually combusting it out? It's not burning anything. There's no fusion in the sun. That's well understood. Proven. Yeah, well, there's no way to prove that there is any. It's only in the flares that you get fusion. That's all the X-rays. Flares, the arcs, and the X-rays, and the microwaves, and whatever result of fusion in the arcs. There's no fusion in the sun. They don't know how the sun works. Why do you? What's special? How does the sun make like? It's a transform. Transforms from some other dimension. It's not burning anything. It doesn't have to. It's a converter.
At the center of every magnet, there is a zero magnetism. You see that underneath the ferrocell. You can see that underneath magnetic viewing film. You can even see it if you were to bring 2 magnets together with a Gauss meter at the center. So, we know what's going to be at the center. Is it going to be a black spot or a gigantic disk of light? What do you think the answer is? We're creating 1 magnet out of 2. You'll notice as I get it closer, hard to keep it from snapping together. I don't want to break the glass. That at first, the black hole gets a little larger. Notice the flux lines diverging. You see that? Now wait, what happens when I bring it together? Look at what's forming before I bring it together. You see that ring of light? As I get closer, let me get it so you can get a better view. As I get closer, the black turns into a ring of light. if I could zoom in so you could see it. Here we go. Hold on a second. Here we go. Ring of light. What you're seeing is the center
Black
of the magnet.
sun,
These two magnets are now
won't you
effectively one,
come?
even though they're separated by a couple of
Won't you
thin pieces of
come?
precision glass. The center where
Wash
no magnetism
away
exists, there's a halo of
rain,
light.
black hole
The
sun.
dark lines
Won't you come?
represent centripetal
Won't you
convergence.
come?
The white lines represent centrifugal divergence. So what you're seeing in the white lines is true magnetism. No, they're moving in the exact same direction, only inverse to your spatial perspective. Nothing. Space is the air inside this donut. The cream filling inside the donut of magnetic divergence is literally the farts, the after effect, the remnant remains, the fecal matter of the loss of inertia, which necessitates magnetic divergence and reciprocation. As Faraday called magnetism, he called it the dielectric field. And oddly enough, one of the first experts in electrical engineering was the guy who got closest, even closer than Tesla, to understanding what magnetism was in its relationship to dielectricity, because only dielectricity exists. Love my flat Earth community because they're asking questions and they're trying to get to the answers, but the truth of it is there is no scientific evidence to break down a flat torus field. There is no such thing. There's no such thing as something being a flat and three-dimensional object at the same time either. Because a lot of them say, well, it's hollow, but it's flat, but it's round, and it's this at the same time. That's absurd. I mean,
I agree. The Earth can't be flat, concave, and convex all at the same time. That's stupid.
how much more are you going to try and force things into your model of it being flat? It's not flat. It can't be flat. I'll explain why. When you break down these two pictures here, showing you field theory 101, this little orange or this greenish looking blue disc right here, I don't know if you can see that bluish disc right here, that's flat right there. This is where flat earthers say they live, on the flat part of a torus field. Okay, so what this is right here is this is the centripetal dielectric movement and zone right here. Centripetal dielectric movement and zone. Centripetal means in. So everything is converging inward, and that breaks it down right here. This is your dielectric plate right here. This greenish, bluish looking flat plate right here is this yellow right here. This is what you're seeing right here. So everything is centripetal. It's converging in on the center point. It's converging in on the center point. On the center point. On the center. Center. Center is the point of creation. Center. So everything's converging in at this center point, which is the dielectric field. It's destroying space, meaning, and this is where they say they live. So everything is sucking in. You can take your idea of a black hole, and this is exactly what you would get. You understand? So what this is, where they say they live, is in a chaotic state of a black hole, of nothingness. Nothing exists here. This is formless energy before it's cast out and expressed through magnetism.
So what he's telling you is that literally flat Earth has no scientific basis. From the very foundation of magnetism, energy, and matter itself, we cannot be living on the dielectric plane of inertia. It doesn't it's like that's the only place we can't be living, is on the dielectric plane of inertia. That's, in all likelihood, that's what the equator of the celestial sphere and the orbiting lights around it, that's probably the dielectric plane of inertia, is where all the planets are orbiting around the celestial sphere at the same altitude as at the same altitude as the four corners of the Earth, which would be, hold on, give me a second. Let me find the best visual for it. Here we go. So the dielectric plane of inertia is probably right here at, along the equator like this. And we've got four magnetic equilibrium points, the four corners of the Earth, which means this would be a stationary octahedron with a rotating celestial sphere. But here's your dielectric plane of inertia right here with all the shit orbiting around it. Right there. Pow. That is your dielectric plane of inertia. And the center point. The center. So we have an octahedron, the north, the south. There's a preference to the north. And since the northern apex is different from the southern apex, that's why magnetically there's magnetic anomalies. And I'd like to actually play another video that shows exactly why. I still want to get to the horizon too. I've got so much to yap and blab about. Talk to me, Jamie.
Yeah.
Before I, you know what I mean?
Yeah, I don't know. It's just all kind of.
I know that's above my pay grade too. So I couldn't like walk into a lab and like prove any of that stuff. You know what I'm saying? But well, what channel am I on? Oh, here we go. All right, that's the problem. Just things to consider. You know what I mean? Like as scientific as flat Earth looks, there's some strong scientific evidence against it as well. And I was just about this one. Okay. So in this video,
hi guys, this is my version of the Earth's magnetic field lines.
Okay, so in this video, you can see that basically this might be why all the compasses point north. Because a flat earther will say, and I've said it myself, how come if the Earth is a sphere, there should be two magnetic poles? How come there's no south pole compasses? And that's quite simply because the magnetic field lines. I'm going to blow this up. I'm just going to read what's on the screen. Not going to do anything more. The magnetic field lines run northward up the interior of the concave Earth surface and exit through a polar hole in the north. This is why we can't circumnavigate north to south. It's not because the Earth isn't a globe. It's because they don't want us realizing we live inside the globe instead of outside, which is why we can't go to Antarctica. That's why the Antarctic Treaty really exists, because if they don't have an Antarctic Treaty, then we go to Antarctica and we prove it's not an ice ring. See, they can't keep us from going to Antarctica, because if we go to Antarctica, we disprove flat Earth. Flat Earth won't work without the Antarctic Treaty. All right. Another thing to think about, like, oh, shit, man, I didn't think about that. Like, damn, what if they just, yep, what if they just fooled you? All right. The concave surface of the Earth and exit through a polar hole in the north. Then they travel southward along the outside convex surface and re-enter Earth through a southern pole hole to complete the circuit. So in this model, we do have holes at the poles. And if there's a hole punched right through Antarctica, well, then that would make Antarctica an ice ring now, wouldn't it? And it would still be a continent at the bottom of a ball, but with a big, huge hole. Plus, I think Antarctica is slightly larger than what they tell us. And with a big hole in it, that would technically make it an ice ring and a continent. And the size would be a lie and all that stuff. So there's real quick. I know I haven't let you done a whole lot of talking, and I apologize for that. But real quick, I wanted to address this issue. I make the claim that flat earthers are brainwashed by fisheye footage, GoPro. And you might think, wait a minute, no, that's the globe heads. The flat earthers are the ones that are aware of the fisheye and the GoPro. They're the ones not being fooled by it. And I still object, because here's how flat earthers are fooled by fisheye. Because while understanding that a fisheye is going to give you false convex curvature, what it does is it also gives you a false concave curvature, now doesn't it? So we know that this is just a snapshot of a fisheye lens camera, GoPro, whatever. And we know that's not the real curvature of the Earth. We're seeing a concave curve there, and I'm saying that's not a real concave curve. What I'm saying, the reason why flat earthers are brainwashed by fisheye footage like this is because it teaches them that this is the curve they should be looking for a concave Earth, which is foolish. Why would you ever expect to see this in a concave Earth? You should only see a convex curve on a convex Earth because there's not more land in the background. See, inside a concave Earth, this is crucial to understand, because you're always going to think you're too smart for concave Earth until you actually think about it. When you actually think that on the inside of a sphere, everything's always rising up and around you. So why would anyone on the inside of the sphere expect to see anything other than a flat horizon? You see what I'm saying, Jamie? Jamie? Did I lose Jamie? No, Jamie's still here. All right, maybe he went to the restroom or something. Maybe I'll just play some music till he gets back. It's important that the audience hear this, but I wanted Jamie to hear it too, because I want Jamie to understand this, and I think he will. Oops. You back, Jamie? No? All right. He probably just went to take a pee. He probably figured I'd be talking for 4 hours, so he probably thought he had plenty of time. So anyway, I wanted to make the point that just because you're inside the sphere doesn't mean you're going to see a concave curvature like that. Because even with this fisheye footage, it's easy to see that this isn't what you'd expect from the inside of a ball. Let's see, how far down is it? Here we go. So there's still more land here. Like, how would, in a concave Earth, why would light do that? How would the light, like, in a concave Earth, you'd still see this. You'd still see a flat horizon inside a concave Earth. So morons like Brendan Daly will say, oh, no curve, no globe. And that's because they're so foolish that they can't grasp, because he's just like a Brendan Daly. He's kind of like a meathead. We're from the same town. I've met this guy. I know him personally. I have the right to say this. He really is kind of a dumbass, you know? Sorry, Brendan, but you're kind of and you threatened my family, so fuck you. But aside from that, piece of shit, you're too dumb to realize that on the inside of a sphere, you're going to answer to me one day. On the inside of a sphere, you should see a flat horizon, and you shouldn't be looking for a smiley face concave curve like that on the inside of a ball. You absolute fool. Okay, Brendan? So when you have actual real balls and you want to come talk to me like a man face to face, even if you only can do it on Google Hangouts, I'm here waiting for you. And I will be back in New Hampshire if you ever want to talk in person. We can settle it man to man. Why you want to threaten my family and then run like a little bitch and hide, right? Because you were supposed to come to my house and kick my ass, remember? And you never showed up, remember? Now you want to talk smack like you know everything, promoting a flat earth? Well, you're a fool. And I'm going to kick your ass on the golf course. So, Jamie, you back yet? No? I wonder what happened with Jamie. Oh, I think he took off. Okay. Oh, maybe he lost connection. I'm not sure. Well, anyway, it was great having you on, Jamie. I don't know if you can hear this, but oh, Brother Ernest says, oh, brother, exactly what he said he was going to do to me. He knows he hasn't got a ground to stand on being a fluffer. Yeah, most people know they don't have any ground to stand on. So, hey, Ernest, you want to join the panel, or anybody else? If you want to join, Eminent, any of you guys want to join Plain Truth? Plain Truth. Hey, if you want to come on here and try to prove your silly flat Earth, you're more than welcome to, Plain Truth. Just leave me your Gmail and I'll send you an invite. Brendan showed up at Jamie's. That's funny. Brendan Daly's not going to show up anywhere because he's right now. I mean, you probably don't want to show your face anywhere. I mean, you probably still care about the Bruins loss. So you're just having a tough time right now. Everyone's blowing loads all over your flat Earth, and the Bruins lost, and you're a bitch. Like, things are not going well for you, but that's all right. You know, we all have struggles. I'm going through some tough times too. So, you know, whatever. It's all good.
Sorry, it was a connection.
Oh, it was your connection. Okay, good. I thought I had lost you there for a minute. Are you there?
Yeah, well, I am now, but I wasn't.
Right. So
yeah, I was out for a minute.
Jaws about the fisheye footage. Did you catch all that?
Yeah, I heard you talk a bit about that. Yeah.
Right. And
just to let you know, I'm going to be getting off in a minute. So.
Yeah, me too. It's been almost like 3 hours. This is crazy. I got to get something to eat. But yeah, real quick. I mean, the fisheye footage. You heard me talking about that. We shouldn't be looking for a concave.
Sorry, we're breaking up now.
Oh, is it? All right. Well, anyway, the whole audience they understood what I was saying. You know, we shouldn't be looking for the concave curve like this in a concave Earth because you know there's more land. You know, I'm sure you already understand that there's more land in the background, and this is exactly what we'd expect from a concave Earth. You know, to be inside of it, we wouldn't see anything but a flat horizon anyway. So. Hey man, it was good having you on. Maybe next time you can host me and you'll get to talk more. I'm so sorry for being like a dick, but well, not that I was a dick, but I wish I would have hosted a more two-sided conversation. You know what I mean? But there's a lot to say. I mean, when you've been doing this long enough, there's a lot to cover. And there's, you know, you can't just be like, oh yeah, concave. Oh, okay, yeah, it makes sense. No, you actually have to think about all this stuff. So, but it was even aside from, even whether we were live or not, this was healthy because now you got to, you probably saw and heard some things that you might not have seen and heard, and it might have changed your perspective a little bit,
Well, I've heard a lot of the stuff like with the lunar eclipse.
Hello?
The bending light thing is.
Yeah, he's kind of breaking up a little bit. I don't know if you guys can hear him. I can hear him pretty good. All right, I can't hear him pretty good. Are you there? Yeah, I didn't catch the last. I didn't catch what you just said. You were kind of cutting out a little bit. Hello? All right. Well, it sounds like we're having some technical difficulties. I'm having trouble hearing Jamie. Are you there, Jamie? Yeah. So maybe I'll just kill it here. It's been a long conversation. So, he's going to be getting ready to go. It's been it's been like 3.5 hours. I got to stand up. This is ridiculous. Almost a half little marathon there. So, hey, thank you, Jamie, for coming on. I'm not sure if you can hear me. Hopefully you can. I can't hear you, but thank you very much for coming on. It was cool to be able to explain some things. Okay, so he just dropped off. All right, so that gives me my answer. And hopefully, people in the audience learn some things. You there?
Yeah.
Oh, okay. Cool. So, yeah, man, it was cool having you on. It was I like that. I like that you're still interested. You know what I mean? Because there's a lot of people that act like they care and, they don't. So you seem to actually care to ponder and to consider all these things. And while your abilities are limited, like myself, your abilities are limited to what you can and can prove, you're at least showing that you're willing to listen and you're open-minded. So I really appreciate that. We need more people like you.
Yeah. Well, I'm just after the truth, really. So, yeah.
It's not easy. It takes time, and humility. It takes a lot of humility. Did for me anyway, because I promoted Flat Earth hardcore, and then to have to be like, oh, whoops, it's ooh, sorry, it's not flat. Sorry about that. I didn't mean to disturb your church and all that stuff.
Yeah.
So, all right. So I have a question for you. What was?
Well,
you're gonna get going.
I'm gonna drop out now. Then.
Okay.
Right.
Cool.
What was it? Yeah, I was gonna get going, but what was the question?
Oh, yeah. I was just gonna ask if there was during this 3 hours, if there was something you didn't already know, what was the most interesting thing that you learned during this 3.5 hour rant of mine? Was there something that you didn't know that you maybe found interesting?
Not particularly. I don't know. It's hard to think of something right now. I think most of the stuff I've already seen before. So
yeah, a lot of it.
I don't remember seeing the diamond sun thing. I don't know. Maybe that one.
Oh, the sundogs. Yeah, the sundogs. And I never showed the diamagnetic levitation either. That's a great video.
I've seen the sundogs, but I don't remember the thing about the diamond sun. Like,
yeah, the diamond shape in the middle. Yeah, that's pretty interesting.
And the other, yeah.
Cool, man. Well, hey, maybe we'll have to do it
Yeah.
again sometime. We're gonna have to keep it much shorter, though. I'm gonna have to do a better job of that.
Yeah. Yeah, it's gone on quite some time.
It's gone on for a while, but hey,
Oh.
lots of people come in and out of the comment section. So, you know, it's good. It's good. It's more traffic.
Yeah, it's in. Yeah, it's.
So I know a lot of your buddies, a lot of your flat Earth. Well, I'm just gonna say it. You know, a lot of the flat earthers that maybe you know or come on your channel or whatever, they're gonna have a lot to say. So, you know, I challenge you to challenge them. Say, hey, you know, you made this claim. Josh seems to have a pretty good argument against that claim. Send them to me. Tell them, you know, tell them they can come educate me on flat Earth. You know, tell them I'm willing to talk with them about it. But yeah, I mean, I until next time, you know, have yourself a great evening, you know. It's It's past midnight where you are now, right? Oh my goodness.
Yeah, you too. Obviously, it'd be like, yeah. What's it where you are? Is it like 7:30?
Yeah, it's 7:30 on the nose, which means it's 12:30 where you are, right? Yeah, it's a 5-hour difference. All right, cool, man. Hey, thanks for coming on. I really appreciate it. I hope we were all able to learn something. And
yeah,
that's
cool. What it's all about.
That's right. All right, man. I'll see you. Take care. Have a good night.
All right. Yeah.